Hey guys, it's Tom from Voxer here, and this will be a quick overview before we will start with the course. So we will start with our camera import and also our character import. For this we will separate the foot so we can use it as a driver for the animation. Then we will create our ground. This will be just a simple plane, and with some more noises it will be looking more interesting. We need then to separate the area where our foot will destruct the area and the outside area, so we don't have to fracture everything. Then we will create our fracturing setup. This will looking like this. Inside here, there will be a lot of small parts and debris that will not necessary for the animation later on. So we will create a little cleanup over here. So all the smaller parts are getting deleted, and all the parts that are not seen from above will also be getting deleted. So this is our area from above that we will see inside the camera. And from underneath, you will see all the parts that are not on the top side will be getting deleted to even make it more faster and cleaner. There will be parts left that are smaller debris like this here. The problem with these parts will be they are also visible on the top side, so we can't delete them, but we will unselect them later on for the animation, so they will be not floating upwards and getting a debris trail behind it, so it will not looking weird. Then we will extract centroid points of all of our fracturing, and with our points here, we will create the selection, which of the points we will animate, which of the points we will not animate. Inside here, we will create an animation completely driven by attribute VOPs. And for this, we will build a controller. So we can control everything with just one controller here. So if I go to my fracture retime, you will see here I can easily change everything up. So I can change my seed. So I have different seed of my bigger debris chunks. I can say if I want more or less debris. I can change my animation up, so it's floating higher upwards or even lower. I can change the animation speed. I can even change the rotation speed. For the outside cracks here, I can also say if I want them or if I don't want them. I can also say my start and end frame here. And after recreating the animation parts here, we will also creating some debris that are floating behind our parts that are floating upwards here. And with this, we can also easily say how much we want. So I can lower the value, for example, or I can even increase it even further. So it's looking more like this. For this, we can also change the rotation speed, and same goes for the smoke. So in here, we will also creating some smoke floating behind our animated debris. And at the end, we also need our pans. So for this, we will also animate our pans that also get driven by the stamp of the foot. The last part we will have to cover inside SOPs is to use the export. So we will prepare everything for stage and make a low poly version out of everything. So this here, for example, will be our low poly version of the destruction. And this here is our high poly version. Our low poly version has the same animation as the high poly version, so we don't getting confused inside Solaris then. Same goes for our pans here. So we have a low and a high poly version. And for everything else, so our debris, our dust, and also our character and the smoke. Inside Solaris then, we will start with importing everything, starting with our camera. Then we will import our character and pans. We will create some materials for this and give it some more interesting looks with some noises. For the smaller debris and the dust, we will create the scattering inside Solaris and also make some other changes in here. And for the lighting setup, we will also use some gobos and the light mixer. And at the end, we will just create a quick render karma setting so you can render it out and make a compositing for yourself. But yeah, with all that said, let's get started. And we will start with creating a geo container here. And we will call it FX destruction, like so. And we diving in. We will import our character with using an Alembic file here. So inside here, we go to selection, and in the object path, we type /geo and import our Alembic file in here. So we get our character, but we will see the character is way too big because we are at values of 125 here. So we have to scale it down, and for this, we're using a transform node. We plug this inside, let's display it, and we're using a value of 0.01. And let's watch the animation here. This is looking good. But we will also notice the geometry only has 18 points. So it definitely has 2 less points here. And the reason is because it's an Alembic file, so it's packed normally. For this, we have multiple ways to unpack it or convert it back. So we can go unpack Alembic delay load primitives, or we could use an unpack node like so. Or another way I mostly use for Alembic is using a convert node here and convert it back to polygons. Now let's select the foot here. So for this, we're using a blast node over here, and we press this icon here to select something inside here. So there are multiple ways to select the foot only. So we could double click on the foot here on one polygon. So make sure you have selected the select primitive icon here. But we could also go to 3D connected geometry here. And then we can only select the foot over here, like so. Press enter and delete non-selected. Great. Now we got only the foot, also with the animation. And we can make a null afterwards and be calling it foot geo, like so. But we also want the leg here on the right side, so we can later on do the cloth simulation. For this, we're using another blast node over here. And let's dive in. And I don't want to select like this anymore, but like so. So I select everything over here. Make sure you only have selected the select primitive icon and the box selection. If you have, for example, the eye here and you select like this here, you will see the back parts are not selected, only the front parts here. So there's sometimes this issue, so make sure you only have this booth icon here selected. If you have something selected over here, you can select even more with holding down shift and then select more, like so. And over here, I also want to select this part. And if you want to deselect something, you can hold Control and deselect this part here, for example. So we really only get this leg here over here. Now let's press enter and delete non-selected. And we only got this leg here, even with the animation. Now let's plug this over here. And we will call it character geo, like so. Let's make a note here. I'm calling it character. And I will increase the text size to large or extra large. I will use large in this case. Get it down a little bit. I will also hide the background and create a box out of it here. And the box will be, we can press C for the colors here and create the greenish color here for the box. Now let's get up so we can create the camera. For this, we're using an Alembic X form here. Press it down. And we have to do some stuff here for this. So at first we dive in and we create a camera. We plug this over here. And let's move up. And in the file name, we will import our Alembic file again. So like this. But you will see nothing will change. And this is why we don't have selected our object path for the camera. And the object path is /shotcam, like so. And you will instantly see the camera is moving away. Now it's really far away, because we also have to scale it down. And for this, we're using a null. And we scale it down with a 0.01 maybe, like this. This is great. But still the animation is missing of the camera. And also make sure the C of the shot cam here is a big C, so it's also working. And in the frame tab, we type $FF for the frame number. So each frame the camera is animated, like so. And also here, where my 240 is, I will type 100. So my timeline is only 100 frames long. Now let's start working on the ground here. And we don't need to display the null here, like this. And for the ground, we start with using a grid. The grid scale, I use a value of 12 on 12. And also the rows and columns, I will increase to around 200. Display them. So this is the grid inside the camera. And we also want to give it some UVs, so UV texture. And we can also display the UVs here by pressing this icon, show UV and textures. And you will see the UVs are way too big, so we can scale it down. I'm using a value of, I guess this is good, 9.6. And we afterwards want to use a mountain node to give the environment a little bit more interesting look. So let's use a mountain node over here. And this is way too much. So I'm maybe using a value of 0.1 for the amplitude. And let's increase the element size to around something like this. And maybe change the offset a little bit. Yeah, this is looking good. And we also want to increase the roughness here under the fracture tab. So maybe something like this. It's looking more interesting. We also want to transform it a little bit. So let's use a transform and we're moving it up a little bit. So 0.01 like so. At the end, we're just using a null again. So we can call it ground. And let's move over the character here. We can hold Alt and drag it over here. So we copy it. And we're calling it ground. Let's select everything, line it a little bit up, and create another box out of it. Line the box up again. And I will also make it green, like so. For the fracturing, we will start with adjusting our ground a little bit. For this, we're using the ground here and pasting it into an object merge here. We need some more subdivision on it. So I'm using a subdivide here. And a depth of around 3. It's looking good. So we can work with another mountain here to give it a little bit more detail. And yeah, this is way too much. So let's lower the value. For the amplitude, I'm using a value of 0.012. And the element size, I can also lower a little bit, like this. Looking good. I think the roughness also can stay at it is. Have a look through the camera here. And yeah, this is looking cool. So for the fracturing, we will work completely procedural as well. I want to have cut out here where the foot is, so I can visualize the foot. And this area I will fracture, and the rest I don't want to fracture, so I have to split the parts here at the start. For this, we're using a sphere, and I'm using the polygon one at a frequency around 15. I also want to mountain them, but before I want to center the sphere, because as you can see, the sphere is not in the middle of the foot. For this, we can grab our foot from here and paste it into an object merge again. And let's use a match size over here. So I plug my sphere in the first input and the foot in the second input. And you will see the foot is now inside the sphere, like here. And we can use the mountain afterwards. So I plug this in here. For the mountain, I will use a value of 0.15 and a really low element size around 0.19 maybe. Yeah, looking good. I also will increase the roughness a little bit more. Okay, maybe something like this. Now let's add a null over here as well. So we can call it ground detail. And let's line them up properly. And we can grab our ground detail here. So I plug this over here. And we're using a Boolean operation here. And I'm using an operation subtract. And we know our first input is the ground. And our ground is a surface. So we switch it to surface. And the second one is a solid object. So we'll let it be on a solid object. But we also need the difference for the hole in the middle. So for this, we're using an intersection from the surface to the solid. Now let's plug them in. For this, I'm going to manual, plug them in here, and also in here, moving the merge over here as well. You can copy the node, you hold Alt and drag and drop it. So let's plug this in here and watch the result. Looking good. That's the ground now. This will be the hole here. So as you can see, there's the hole in the middle. And this part here is fitting perfectly in. But the ground here is a little bit too big overall, so we can also lower it a little bit. So we're using a group for this. I run it over the primitives, and I want to have a bounding region. I'm using a value of 5 and 5. So I guess this is enough. Maybe I can move it a little bit in the back here, like so. And let's blast them out. So we're using a blast node here. Plug this inside, and select the group here, and delete non-selected. So we only got this part here, and the rest will be deleted. We're using a file cache afterwards to cache both stuff outside. But to not use two file caches here, we can use another technique here. So we're using another group here. We're calling it ground outside on the primitives. We're merging it together. And now we can use a file cache over here. So I'm using /ship/$s. This will be also just $s, and this will be my ground over here. It's not time-dependent cache. This single frame. This is looking good. And we can hit save to disk. And this will be just ground underscore cache, like so. And save to disk. And now we can use a file node afterwards. We can grab our ground cache here. And let's use a split node afterwards. So we plug this in here. Use the group outside. So we can split it up. And this will be my null all outside. And this will be my inside. Now let's line it here a little bit more, clean up. Something like this, maybe like this. Looking good. Now we got our ground here, and we will start with the scattering for the fracturing. So for this, we're using our inside here, and again, paste it into an object merge. And we're using a scatter for this, like so. But this is way too clean, so we don't use relax iterations to make it more random. And maybe a higher count, around 1100. Yeah, looking good. But we also want to have a custom destruction where the foot is, so we need to delete the points here and create some custom points for this. For this, we're using a group node over here. Plug this in. And now we need our foot again. So we go up to our foot over here and paste it over here. And the problem is what we have with our foot, if you will see it here. The stuff here is moving. So we need to freeze the frame. So for this, we're using a time shift at frame 12, for example. And we do the same down here. And to always have the same values, we can just copy the node with all the values here over. For this, you have to hold Shift, Control, and Alt and drag and drop it. So with this technique, you have referenced all the inputs here. So now if we would change the value here to around 15, for example, you will see the value here is also now 15. Now let's change it up to 12 and be using a polyfill over here to make the hole disappear here. And we want to have it on a single polygon. So we can use a VDB from polygons to make a VDB out of it. The value is way too big, so we're using a value of 0.0025 maybe, looking better. And let's line this here up properly as well. And we're using VDB reshape SDF. And let's plug our VDB from polygon inside and increase the offset here around 50 maybe. And we can plug this into the group. to use it as a detection for the points. And we're using volume detection here. The group also has to run over the points. And now you will see the foot is exactly here and selecting all the points inside. Great. Now we can blast them out. So using a blast node over here. And let's blast them out here. You can also use a group delete afterwards to clean it up. And let's use a merge here to plug this in here. For the points inside, we also use the same technique again with the VDB reshape. So I plug this over here. But I think I will use a lower value here, around maybe 2, looking good. And let's use an intersection analysis. We plug the foot in the second input. And for the first input, we need our ground, but not our detailed ground, but the normal ground, because we just have to scatter some points on it. So for this, we plug this in here. And you will automatically notice the area where the foot and the ground is intersecting. There are some points now. So this is really good. And we also don't want this much points here. So we're using delete node here, run it over the points. And I want to delete a random amount here, like maybe something like this here. I guess we're using 92, looking good. And we can also change the seed if we want to. But let's first use a point jitter here. And for the point jitter, I don't want to jitter it over the epsilon axis, so just in the z and x direction. And for the scale, I also will lower it to around 0.05 maybe. The problem we have now is that our points are not on the ground anymore, and for this we can use a ray node. So we're using the ray node and plug our point jitter after I'm using a null here, calling it PTS jitter, and I just do it because I like it clean. So I plug this into an object merge here, plug this over here, and this over here. And in the ray node, we have to go to minimal distance. So the points are on the ground again, and we can plug this in here. So now we got from this scatter points here, where we don't have control over the middle, to a point where we have control of the middle and also can use the point jitter here to increase the value, lower it, and all the stuff. Now let's use another null over here, and we're calling it PTS. And I like to make this here maybe to a bluish color, because I only like the real outputs in a red color, so I don't get distracted by myself if I just use it inside here somewhere. Now let's move on to our fracturing. I will make the screen here a little bit bigger to work on. We will start with our inside here again. So I use it over here and plug this into an object merge. And into an object merge, we're using an poly extrude, like so. And I will use a value minus 0.03 maybe. And I also want to have my output back out, because you will see here, the back here is like in whole, but with this, lost again. And one thing I also want is the front group, so we can use it like this. Now, you also saw it, the geo is reversed. So over here, if we plug the reverse inside, the polygons are flipped. Now it's working again. And we're using some normals over here. So plug this in here. And a null will make it bluish again. And calling it geo fracture ready, like so. Now we also need our points here. So I'm using, paste it over here. And I need a point jitter again. And for the point jitter, I only want to scale it in the epsilon axis by a value of 0.02. And in the transform afterwards, we need to copy the parameter here. So copy parameter. And we paste it in the translation here, in the epsilon axis, paste relative reference. And inside there, we use a minus before the channel function and the /2 afterwards. So we divide it by 2 and it's a minus then. You will see it's -1, the half of the input of here. So let's plug this inside. And now we can use a Voronoi fracture here to plug our points we created here inside. And for the geo, we want to have the inside of the fracture to use it as a cutter geo. For this, we just need a bounding box, so we have a bigger area for all of this. So we will increase it here a little bit to around maybe 0.15 and here as well. Let's plug this in the brown here. And you will see now we got this bounding box here out of, I will show it like this. So this is my ground and this is the bounding box around. And the reason why it's so big, I maybe can lower it a little bit more. Maybe something like this here. Yeah, I guess this is enough. But the reason why it's so big is because we need the cutter geo outside of the original one. So there are no weird cutters inside then afterwards. We can watch the result here. And this is looking pretty good to me. So we can just use the inside. So we're using a blast again. And we got the inside here and delete non-selected. So we only get this inside here. But I think the values here are way too strong again. So I think I will lower it again to maybe a value of 0.015. And also for here, this is looking way better. Now let's fuse the points all together so we can delete this weird looking glitching geometry here. So we will start with the fuse, and we use a clean node afterwards. So we can delete the fix overlap, but don't the overlap pairs here. So you will see it's looking good now, and there are no issues anymore. We got big faces here, and before we remesh, we want to set one UV on each of the face here. So for this, we're using a UV texture, and this will be looking really weird now. We can display it with pressing this button here. But if we set it to face only, you will see on each face is now an UV texture, and this will looking really good later on if we give it more detail. So for this, we will start with a remesh here and plug this inside. And we need to load a value, and I think a value of 0.006 looking really good to me. And let's add some mountain nodes afterwards to give it some more variation in the cutting. So for this, we're using a mountain node here. And I don't want to cut along the vector normal. This will looking really weird now. But I'm using a value of 0.03. And element size I will also lower a little bit to around 0.15. Looking way more interesting now. But let's also increase the roughness a little bit. And let's copy it down again. Plug this inside. And lower the values again. So I'm using an amplitude of 0.01. And the element size I have 0.03. So this is looking really good to me. And we can use a Boolean fracture over here. But first, let's line them up properly again. So it's looking more clean, like so. Do my Boolean fracture over here. So I plug this inside here. And this will go inside here. But for this, I'm going to manual mode again. Plug this over here. And let's check everything. So my first input will be a solid surface. We know that. But my second input is a surface only, because they are just planes. So yeah, this will be the cutter. But I used the Boolean, but I need the Boolean fracture here. So let's do it like this. Little mistake over there. But let's check it again. So my first input is a solid surface. That's correct. And my second input is just the planes here. So it's just the surface here. Inside and outside it's also good. My piece prefix is piece. Looking good. Now let's use a file cache over here. And again, we don't need a time-dependent cache. And this will be /$s and also /$s. And I will call the file cache fracture maybe, like so. Or fracture cache to have it consistent. Let's save the disk. And this was pretty fast, so we're using file node here. And grab our file cache here. Let's switch back to auto mode. And this is our cutted geo here. Let's not display the UV here, so we get a better view of the cutting. There. We can also watch it with an exploded view. So if you want to make some changes, we can do it easily. But this is looking pretty good to me. The only problem we have now is that we have these small parts inside here. And we can delete them pretty easily. But the problem is also we have some of them in the top area, so connected to the surface. And we don't want to delete them because then you don't see the whole geo here as a clean geo. But let's start with deleting all the bad parts we don't see anyways. For this, we first using a clean node to delete all the not seen points we don't need. So we have some points there sometimes. As you can see, we got 634, and here we got only 609. So some of the points get deleted. And now we can use an attribute promote here. And I want to promote my normal here from the vertex to the primitives. So my normal. And I don't want to delete the original. But now I have normals on the primitives. So some of them looking upwards. The bottom here looking downwards. And we can display them. We'll see. They here are looking upwards. I will maybe change the normal vector here. Something like this. And all the stuff and all the normal faces that's looking upwards here, I want to select. So for this, we're using a split top. So for this, we're using a group node. And inside here, I run it over the primitives. And I want my normal that are looking in the epsilon direction. So point epsilon is bigger than 0.75. Now you see all the points, all the primitives that are looking upwards are getting selected here. The only problem is, if we watch toward an exploded view here, you will see there are some points sometimes in the cutter geo that's also getting selected, and we don't want them. So for this, we can use another technique. First, we call this group here split, and we're using another group here. And this will be also my split here. And we're using intersect with existing. And let's use the group outside here. So all the stuff here are getting deleted. The reason why we don't use outside only is, you will see here, I got the group outside and it's selecting everything. Also bottom one because everything here is outside, but we only want the top part. And with this technique, we only selecting the top part here and separate them from everything else. The cool thing we can do now, we creating an attribute now on the top part, and with all the geo that's connected to the group here or to the attribute will not getting deleted, but everything else will be. So everything that have a surface on the top will not be deleted or touched, but everything else will be. I can show you an example here. So we're creating a sphere, and you will see the geo here, and I'm using a color, and the color will be black. So now I'm using a transform, move the sphere here a little bit to the side, maybe like so. Let's merge them together. And if I have, for example, I'm using a color again, and I'm using white, but only on one primitive, for example this, and this piece here is now this has also to be primitive, and this has to be primitive as well here. And if this here are two pieces in the fracturing, and this here is the top part with the attribute, I can easily use a connectivity now to know how much pieces I have. In this example here, you will see under the primitives tab, if I go to my class attribute, I got a 0 and a 1 because I only have two pieces here. I mean, I could also like put another one inside, move it more to the right, and you will automatically see inside the class attribute, we got from 0 to 2 now. So it's detecting every single piece in here. The stuff we want to do now is we want to promote this attribute from the primitives to the primitives, and this will be my CD, but I want to have the maximum value of everything. So I have the maximum value, and if I plug my class attribute here, you will see this sphere getting white because it's connecting to the top side in this case, and everything is now the top part. So we can use it in here as well with the same technique. So we start with an attribute create, and let's delete the explode view here, plug this in here, and we're using our split group we created, and the value of 1, and we call it top. The value is 1, and it has to be on the primitives and also an integer value. Now let's use an connectivity here like we used before, and we're using it on the primitives, and this will be the class. Let's promote the attribute. So attribute promote, again from primitives to primitives. It has to be my top attribute we created, and the piece attribute is class again. We want to have the maximum value. And if I visualize it now, my top attribute here, you will see some of the pieces are not the red color because they have the value of 0, and they will not be visible on the top here, but only on the bottom part or inside. So now let's blast them out. So if at top this be 1 on the primitives, so delete non-selected, and you will see some of the stuff here inside, and in the bottom will be deleted. They will not be visible anyways, but there are a lot of small parts here that are not visible, and they're just really ugly and not really cool for the animation later on. So great, we separate them. But the problem we still have is there are also some small parts in the top here. So if I go to an exploded view and delete the top attribute here, you will see there are also these small parts here, for example. And if we want to have a cool animation later on, we don't want to have these parts here floating up in the air because we only want to break the big pieces here and a trail of small debris afterwards. And for this, we can also use another technique. But first, let's delete some attributes here. So on the primitives, we want to delete the class attribute and my normals on the primitives because we don't need them anymore. We only need the normals on the vertices. And I can also delete the top attribute here. So now let's use another connectivity here because we got a new piece order here. And we use a measure node afterwards. And we want to measure the volume here. So we go to volume, and we want to not per element, but per piece. And the attribute is class again. We got our volume attribute here. And you will notice, because we ran over the primitives, the volume has a pretty low value. So for this, we have to go to an attribute create. And I will use a value of 1 because I want to deselect, so I call the attribute deselect, a volume piece at volume will be smaller than 0.00001, for example. I guess I even have to go with 10 again. And if I use a blast now and use a primitive here and use at deselect will be 1, delete non-selected. I also have to type it here correctly, like so. We can watch it into a blast node again, so we can troubleshoot it. I see the problem. I also have to write this here again correctly, so volume. And if I watch it now here, you will see only some parts getting deleted that are smaller than the other ones. So I have to type 10 again. So we got some small pieces here. And I think this is looking pretty good. You'll see the holes here, but we don't use the blast node here. We just create an attribute on these pieces. So they are pieces getting not selected in the destruction later on. Maybe I'm using a value of 0.3 here. Delete unselected, and yeah, this is looking pretty good. So only the flat pieces here getting deselected. So they are not like these lines here floating up, but also not the small pieces here over here. And not the weird looking pieces like this here. So yeah, this is looking really good. Now let's delete the blast and also this blast here. And we can use another null here. And this would be my fracture. And we're using an extract centroid. Because of each piece, we want to extract the centroid point. So I plug this in here. This is how it looks now. And it doesn't even matter if we use the name attribute or the class attribute here. But for this case, I'm using the name. And afterwards, I also need an wrangle to create one more attribute. So I type e@id underscore orec for original will be my ptnum at ptnum. And now you will see on my points, I got the attribute id original from 0 to all the pieces numbers I have. Now let's use another null here and we call it pts1. And let's clean everything up. So for this, I'm using my character node here, calling it fracture. Maybe I will make it a little bit bigger here. I'm using an extra large text size. And for the character here, I'm using the text box again. And I'm calling it round. And this will be my PTS. And the last one will be my fracture. Now let's select everything here. And we can create another box out of it. And let's make it in a dark gray maybe. Yeah, looking good. The only thing I forgot in the end here was I also need on the extract centroid my deselect attribute here. So I can plug this on here. And we can also visualize this once again. So let's give it another color. I'm using a ramp from attribute, min and max. And now you will see there are some pieces that are red that's getting deselected here. And the rest will be blue and will be animated. Now that we got our points from the destruction, so let's create a setup to select some of the points for the destruction so we can use later on also a controller for it. So for this, we grabbing our points here, PTS1, and I will plug this over here into a new object merge. And this will go into an attribute warp here and into the first input. Now I also need my foot again, and I think I will copy it from here, copy everything over, like so. So I got my polyfill here, my time shift, and now let's create a 3D from polygon again, like so. And I'm using a value of 0.005. I will use fill integer again, just in case, and use world space units for narrow band, and using a value of 1 here. Now let's reshape it again, VDB reshape SDF, and plug this in here. I can use this here now for my second input, and I will call it select by proximity, and we can dive inside. We need the volume sample file here, and our volume is in the second input, and we plug this into the file name, and the position goes into the sample position here. Let's also use an add afterwards, so we have an offset, and a fit afterwards to fit everything inside, and a ramp in here to create outside a ramp for everything. So this will be a spline ramp, and I call it controller here, and this goes into the CD. Now let's move up and select the proximity here, and I will increase it here and move this over here maybe. And you will instantly notice that around the foot is white, but the foot and outside the area is also black. So we can select points out of the white stuff here to only select some of the points here for the destruction later on. Now let's create something for this. So we're using another attribute verb, and we plug this in here. And for this, we're using a multiply of the color. So color, and we need our ptnum. So an add for the ptnum, and this will be after we promote it, again with middle mouse button pressing on it. We can call it, I guess this will be my seed here. I will give it a little bit more space. I can also work like this, so we can see it better. And we need a random over here, and also a fit range again. For the fit range, I will promote everything again. And let's plug the fit range into the multiply second input. And the multiply goes into the color here now. Now let's move back up, and we will watch everything. And if we use a blast node here, and we call it add CD, will be bigger than 0.5, and run over the points and delete non-selected, you will see we select some of the points here, and we can change it with the seed, really cool. And we could also give it more points, or even less with the values here. So just play a little bit around, but later on it's more important to use them. And we could also like increase it here, the range of them. But yeah, now we just want to create also a normal for the points. So for this we're using an attribute wrangle. And I want to have the normals looking away from the foot. So if we would create some normals, so at n will be set to 0, 0, and 1, like so. You can see all the normals looking in this direction, and I maybe can increase the visualizer a little bit more, like so. And now the normals are looking all in this direction. But we want to have a controller for the points, so we can control where the points are looking at or looking away from it. And for this, we're using an add node in here and create one point. And let's plug it in the direction where the foot is. So I guess the foot is maybe over here, but we can also display it. Maybe using this foot here. So yeah, it's pretty much in the middle of the foot. And from here, I want to create a destruction. But now let's also create an up vector. So at up will be 0, 1, and 0, like so. And let's create a vector out of the point we created. So vector, we call it pos. And this will be my point from the first input, because this here is the input 0, and this is the first input. So I need the position attribute, so p, and from the first point, like so. Now let's create our new normal, so at n again. And this will be normalize. Now we normalize our position attribute of the points minus the new position attribute of the point we created, so minus pos. And we want to also multiply it with set 1, 0, and 1 again, like so. And now you will see that all the points are looking away from this point we created. And if we move it around, you will see it's working perfectly fine here. And we can work on the destruction with this. Let's create a new null here. And this will be my res PTS. I'm using a split node afterwards. And inside here, we're using the same technique we used in the blast node. So at CD will be bigger than 0.5 the points. So we only got our points here. And I create a null over here. And this will be my selected PTS. And this will be my other PTS. So we got all the points that are over, and the points that are selected by us. But I think the points are way too much here. I will maybe lower them a little bit more, like so. Maybe increase the range here a little bit, just slightly. So we will let it stay like this. Let's make it clean again. So we paste over our factor here, and we call it setup PTS. Make it clean here. So select everything, move it down here, and create a box out of it. I will also give it the same colors as for the factor, like so. And yeah, it's looking great. Now let's also create a controller for everything. So we're creating a null over here, and we're calling it controller. And inside here, we need some of the stuff. So we don't have to go in all the nodes again and again. The first thing we need is an integer value. This will be my time freeze foot. And I will paste it over here and apply it. And the value will be 12. And let's copy the parameter and paste it into this time shift here. So paste relative reference. And now you will see we can control all the foots here. For example, if we look through this foot here, using the first one, so like this, we automatically can control all the stuff here for all the whole setup here. Now we also want to select the proximity, and then maybe want to use here also an offset like this. But let's use this here again, and we need the ramp float, and we're calling it proximity, like so. Let's apply it, and we create nearly the same values we used before, like so. And we copy the parameter again, and right click on this here, and paste relative reference. So now if we control it here, we also control it down here. So if we watch our selected points here, we can use the controller to increase or decrease the selection range. Now let's go back into the parameter here, and I will make some folders also to make it clean. So this will be my time folder, and I want to have it on simple. Let's plug the feed inside. And I also need a folder for selection. So selection PTS. And let's plug the proximity inside. I also want a float for the offset. So I'm calling it offset, like so. And the offset will be 0.01. And I copy the parameter again and paste it in here. And let's also change the values here. So we need 2 more floats here. But we could also use, now let's just use 2 floats here, like so and like so, into the selection PTS here. And we can use horizontally join to the next parameter, hit apply. And now you will see we got both of them. So this will be my min, this will be my min input, and this will be my max output. So let's use this here. to go inside this here and use it on paste relative reference. And the same goes for the other one, but I firstly will increase it to 0.14 was it maybe, and this here is 0.65, I guess. So let's copy this parameter as well and paste it in here, paste relative reference. So now if we watch our endpoints here, we can go to our controller and change the values here. Maybe I want to adjust them a little bit. So the range will be from 0 to 1, and same for this here, so they're not too big. And also the offset here maybe, but the offset can maybe also go to 0.1 is enough, like so. So I can increase this here or decrease, and I maybe also want to go into -1, so -1 like so, minus 0.1, so it's in the middle, but I can also go outside or more in the middle here. Now I can also control the depth here, or with this here, and I can increase and decrease the selection size. Really good. I will also make a controller panel here, so I paste it over, calling it controller PTS. And let's make the color of the box maybe red. And I guess I will also make the text a big text here. So I always find the controller here and make it maybe green. So I always see the controller. One thing I completely forgot was the seed value. So we also need our seed here in the controller. So let's again use edit parameter interfaces. And I'm using an integer value for this into the selection points. Let's plug this over the offset and we call it seed, hitting apply. And I'm using a value of 8 now. But I also want to increase the range here. So on the seed range, I will use maybe 1000. So I can go wild with this. And also for the selection PTS, I'm using the simple border here, like so. Now let's copy and paste the seed here. So copy parameter, going inside here into our attribute VOP1 and paste the seed, paste relative reference. And maybe I will call it select by random, like so. And this is looking good. Now let's animate our points here. So we're using our selected points and paste it over here into an object merge. And also our other points, we paste it down here as well. Let's merge them together. And we're using a null afterwards, like so. And this will be my animated points. And we're using a sort. So we need our original attribute here, point sort by attribute. And this will be my ID original. And let's copy this animated points over here. We also need the rest points on the right side from this. And our fracturing, we also need here into an object merge again inside here. Now let's use transform pieces. And we can use our object merge down here. The animated points going inside here. And the rest points goes in here. Now we got our normal ground back. But the cool thing is, if we're using an animation here, for example, this transform, we can move some of the points we selected here up and down. And this is pretty cool. And for this, we're using now a procedural way to animate them. So they are moving to the right here and floating upwards, also rotating a little bit. And for the other points here, we're using a technique to drag them down in the middle where the foot is. I think we should start with the points that are getting dragged down here. And for this, let's make them white first here. And later on, we also need some other points inside here. So maybe let's cover this here before. And for this, we're using our foot again. So I need my foot from here and paste it down. And this will be color white. And this will be color black. And if you're using an attribute transfer here into our points, into our selected points here, we can plug it in. We're using only our CD and maybe a distance of 0.019. And you will notice only the points that are really near or close to the foot are getting black. And we can deselect them with the group. So we're using a group over here, running it over the points. We're calling it deselect. And the base group will be at CD will be 0. So only this point's getting selected. But we also have the other points with the deselection attribute. So we can watch it here. And we got 3 points here. So let's also add them to the group. And for this, we're using another group here. Again, using the same name from here. But we don't want to replace the group, but we want to merge them together. So onion with existing. And we're using add the select. This is our attribute, will be 1. Now let's watch the group. And we will set it to points. And now we got the other points here around. And we can split it up. Now on the split here, and maybe give it a little bit more space like so. We're using a null here. I will make it bluish because it's only inside this tree here. And I'm calling it deselection. Deselection. like so. And I'm using these points over here, but there are not points inside here yet because we have to merge them in here and invert the selection. So inside here are only the selected points and the rest will be over here. So now all the points here are white, getting grouped together again. And if we watch our result here, and for example now using a transfer over here, you will see the small parts are gone now. And we're only covering the big parts, big chunks. So we can also use them later on to use the debris following them. Now let's animate the points over here. And for this, we again using a procedural array, and we need our foot for this. Let's place the foot down here. And it's already black, this is good. But we need to make the foot a little bit smaller. And we also need a grid over here. So the grid will be, I guess, 1 and 1 for now, and rows and columns by 50. And let's use a point deform. So we will plug the points into the first input, the grid into the second input, and into the third input. But I will give it a little bit more space. And the second input are my rest points, and this here is my deform points. And we can deform these points now, for example, again with a transform. And if I would only select some of the points here, maybe something like this, this, and this, and move them up here, you will see they are going up. But the cool thing in the point deform, you will see they are also going up. But the problem is the grid is not matching our points, and we don't want to do it manually. So again, we're using a match size for this. So we're selecting both of the strings here and calling match size because we want to match size the grid to our points. So the points going into the second input, like so. And we only want to cover the x in z direction, not the epsilon axis. And if we watch the result now, you will see we got our points that going up here, and the rest is still on the ground, looking really good. Maybe I want to scale it up a little bit, maybe something like so. It is looking good. Now let's use our foot to drag the points down around the foot. And for this, we're using our grid here with the rows and columns. And the foot is already black, so we can use an attribute transfer here again. Goes into the first input, and the foot goes into the second input. And everything will be going black now because the foot is black and the condition is really high. But we only need the CD attribute here and the really low value. But the foot is maybe also a little bit too wide. So we're using transform for this. And into the pivot point, we type, because the pivot is, if we press enter here, the pivot is on the 0.000, you can see here. But we want to have this in the center of the foot. And there's also a procedural way to do that. So we type $CEX for the x-axis. And also here in the last part, $CEZ, like so. Now it's in the center. And we can scale down the foot on the x, and maybe a little bit on the z-axis, like so. Let's also go into the attribute transfer, and we're using a value of 0.1 maybe. Maybe the foot is way too big here, so we're using a value of 0.1. This is looking way better. Now we can select the points, here, so they are black. And they're not moving down now because we need a VOP for this again. So we're using an attribute VOP. But we can use the color now to move them down. And for this, we're diving inside. And we plug the position into the position. And we want to add that the points are getting dragged down here by the color. So we need our color going into a fit range. And my 0 should go down. And I only want to move them into the epsilon direction. So I only want to use one of the colors. So I'm using back to float here. Plug this in here. And in this case, it's not necessary which part we use. But we also need it over here, like so. And we only plug the epsilon in here. And the float to vec afterwards. Again, only with the epsilon inside here. And the rest getting connected to each other. So the x-axis goes into the x-axis, and the z-axis goes into the z-axis again. But the cool thing is now, if we plug this in here, you will see it's going up. But the problem is we need the destination to 0. But this direction needs to get dragged down now. And you can see we can control now this part here only with this scalar here. So we can promote it over here and calling it position. Now let's move up. And I'm maybe getting back in so I can change the float rate to minus 0.3 and 0.3. And we can select the attribute VOP here and control it now. Maybe something like this. And the cool part is, if we're using an attribute blur now, we can also soften it a little bit. So I'm using a value of 4 maybe. Let's drag it more down. Something like this. Maybe using a value of 6. We can also widen the foot here a little bit. we're using a value of 2, so it's a bit wider. Maybe a value of 3 or 2.5 maybe. Yeah, something like this. But we don't want to animate it with this part here, so we're using something different. And let's use a blend shape over here. And let's plug this result into our transform. So we're using a null afterwards. And this will be my grid. And I will make it blue again and paste the grid into an object merge here and plug this into the blend shape. If we change the slider, you will see we can change the result here. And this is looking cool, so we can animate it. So we start with an animation on frame 1 on the blend of 1. And we go up to frame 48 and change it down to 0. Now we got our animation. But let's also speed it up a little bit. So pressing Shift and type on blend here. We're getting our animation editor. Let's drag this here down a little bit. This over here. Something like so. So it's a little bit faster at the start and slows down at the end. Great. And the cool part is, if we watch the points now, you will see the points are getting dragged down. And if we watch the result in the transform pieces, you will see nothing happen because we have to delete this part here and plug the point deform inside. But now you will see the points are getting dragged down here, and it's looking pretty cool. Now let's give it a little bit more space over here. And into the deform, we only want to have our normal and our up vector, not everything, like so. But we also want to change the of the blend here. So we're using another blend shape over here. Plug the point deform input into the second input. And we're only using our points into the first input, but before we're using an attribute copy. So we want to copy the up and normal vector on here. So we're using up and n on the points. And now we can plug this in here. And you will see nothing will change because now we only can change the value how far it should go down over the time. So the maximum should be maybe something like this, but let's watch it in the result. So we're plugging this here into the merge again. Going to our transform pieces. And we have now a slider to control how far it should go down. Maybe something like this here, or maybe like this. And this is the animation now for the foot. And if we maybe watch the wheel foot here, you will see something like this. And one thing we can also add is after here, we're using an attribute blur on the CD, something like this. So this is a little bit wider. You can even increase it a little bit. So something like this. And also using an attribute warp here for the color control. So this will be my CD. And this will be my, let's go into the CD here. And we're plugging the CD into the CD and using a fit range. But my black point should be earlier black. So we can move the destination bin up. And for this, we're using promote parameter. And we can move this here a little bit up. And maybe something like this here. Looking good. Let's watch the end result into the transform pieces. Yeah, this is already looking pretty cool. We can also watch it through the camera. The foot goes down, then bam, construction happening. Now we can set our dir attribute for our points that are floating up. And for this, we're using an attribute warp here. And we're calling it dir for direction. And now let's see in which direction the point should be floating. I will give this here also a little bit more space, moving it up. Because we also need to add a point. So let's add this point here with an add node. And a transform after the point, so we can move the point around. And I want to have the point inside my foot again. So I display my foot, selecting my transform of the points. And let's move the point into the foot here, something like this. And let's plug the transform into the second input. We can also make it procedural again, so we're using a match size. But the problem is we also want to drag it down later on and we want to have more control over it. But the base form we maybe can add. So let's do it. So I'm using my null here. And maybe I will change it that a little bit up again. So I'm using this here and paste it over here. And this will be my freeze foot. This will be my freeze. Because we have this foot over and over again, but not with the color here. But we can use this freeze foot and paste it in all the freeze foots we have. So inside here, we paste it down into an object merge and plug this in here. We also have our foot, where's our other foots here? We also have the foot over here. So let's paste it down into an object merge again, into the polyfill. Can delete this here. We have the foot over here, and we can plug this into the color. And we have the foot over here, and we can again plug this into the color. Because all the foots are the same here, so we don't have to paste them over and over again, and we can just select this global freeze foot here without the color again. And in the controller, we can easily change up this value here. So it's pretty cool. but I just have to go into here, copy parameter again, and paste relative reference. And if I change the foot here now to value of 10, for example, this should go to 10 now. Okay, right, it's working. Let's change it to 12 again. And we're using our foot inside here again, and a match size only on the Z and X direction, but not in the epsilon direction. So the point is here in the middle. And afterwards, we're using the transform, but we're using a new transform, like so. And the transform should be in the middle of the point. So for this, we're typing $CEX, $CE epsilon, and $CEZ. And if you want, you can also go to this icon here, go to legacy preset and save it as a new preset. So you don't have to do it manually all the time. So you can just use the preset then. And it's a faster way to adjust it. Now let's plug the point into the door here. I will move this here a little bit down, like this. And inside the door, we're using an subtract because we want to subtract our position from the position of our other point here. So we're using import point attribute here, and we're using the p attribute and the constant value of 0 because this is the point we're using, and this will be an integer. So we only have 1 point, so the point number will be 0. Let's plug this in here. And the result goes into the second input. We also want to use another part here and an add after the subtract. And we want to add the noise over here. So we're using our position into a turbulent noise. And if we're using a bind export over here after we normalize the result, and we will call it dir, and this will be a 3-float vector, we can move up and display our dir attribute. If you don't see it like this, you can go into with right click on the marker here onto the dir attribute. Just change the type to marker. The style will be in vector, and you have to type the attribute inside here. So you got the same as here. Now the points are looking away from here, but you can also use the transform to make them look up now, down. This is a pretty cool thing. And we also want to add the noise here a little bit. So let's use the noise. We promote the parameters here, something like this. And let's plug this into the add here. And we got the noise. But I think I will use a 3D noise. Let's go up. And we will change some values. I'm using a simplex noise. Increase the frequency a little bit. I will lower the amplitude, maybe to a value of something like this. But I will increase the roughness a little bit more. And the rest can stay as it is. But now it's a little bit more random and has a cooler look. Alright. The next thing we want to add is the length of the dir attribute. And for this, we're using another attribute drop. And we're calling it length. And inside here, we're diving in. We again need the same setup over here. So let's plug this down. But we want to have another control for this. So let's plug this down here inside the length. And we need our point attribute here. So we again using import point attribute. Plug the second input into the file. And for the ptnum, we're using a constant value of 0. And this will be an integer. Now let's use the distance between the points we have and the points we imported. And we want to fit the range. So it's only from 0 to 1. And a ramp afterwards. So ramp parameter. This has to be a spline ramp. And I will call it control. And let's multiply some stuff together. So we're using a multiply. And we will start with our dir attribute. So I'm calling it dir. This will be a 3-float vector. And let's plug this into the first input. And at the end, we're using a bind export. And this will be again a dir attribute and a 3-float vector. And plug this in here. For our other multiply input, we need our position again. And we again using a turbulent noise. And this has to go into a fit range. I only will promote the min and max. So let's press this here and type min and max. And we will plug this into the second input. And you will instantly see the points getting smaller because of the noise. But we also want to add the ramp here. And let's also promote this parameters here. I think all of them a good control then. Let's go up. And I thought I changed it to a spline ramp, like so. And the first part here goes up, like this. For the min and max, I will also maybe change some values here. So I go inside and change it to -1, the min. So I have control over the min to also go into the minus direction. And for the max, I also will decrease it a little bit to maybe around 0.7. Now let's increase the frequency after we change it to simplex again. So you will see we got a more interesting look for the length here. And we will maybe decrease the roughness a little bit, but the amplitude can stay as it is. You can also change the offset here until you find a result you really like. But this has to change later on. But now we can animate our points. And for the animation, we're using again another attribute drop. And I will call this your animation. Now let's dive inside. And we will use an add from the position to the position because we want to add some position changes here. And for this, I will move this down once. And I want to use a random number of my PT num we have. And let's plug this into a fit range. And I will promote my destination min and max. I will also call it min and max. I think my min goes also again to -1, just in case. Let's multiply the result here. And I want to have my first input, my dir attribute. So let's type dir into a bind. And we're using a 3-float vector again. And let's plug this into the multiplier. My fit goes into the second input. And let's plug this into the add here. But nothing will change because we also have to add a multiplier for the time we have now. So for this, we're using the frame over here, plugging it into the fit range. And the source max, I will promote the parameter. And this will be my duration. And a ramp afterwards. Again, a spline ramp. And let's plug this into the third input. And the fourth input we will promote, like so. Now let's head back up and watch our points here. And nothing will change because our ramp is 0. But if we increase the ramp here, and the duration will be 100, so it goes over 100 frames. And our global multiplier also goes up. And for the global multiplier, maybe using a value of 6.5 here. You will see the points are floating up here. This is looking pretty cool. So if we watch the result in the transform pieces, let's fix the camera here. So we're using a value of 0.001. And the points are floating up 1 frame too early, I guess. So let's go in here. And I will change it to 1. So after frame 1, they will start. Something like this, looking pretty cool. I mean, I can also promote this attribute and calling it start frame. This has to be an integer value and a range from 1 to 20, I guess. Like so. Now let's make a 1 out of it. I don't want to display my dir attribute anymore. So I can go to here and not display it anymore. And now my destruction goes like this. And this is already looking pretty cool. But you will see the parts are not rotated and they are too flat in the direction. So we can go in here and drag this point more down. So they're floating more up, like so. And with this point, we can easily control it procedurally. Pretty cool. And inside the camera, this is also looking really cool already. And if we want to go into our controller, we can also easily change the seat now. So we can move through here until we get a result we really like. We also can add more points or less points if we want to. And all the stuff. Maybe we can do something like this here. Decrease the points, increase the points, all the stuff. But now let's add the rotation at first. So for this, we again using an attribute verb here. Let's plug this in here. I'm calling it rotation selected points, well, PTS. And let's dive inside. I will start with an bind export here. And this will be my rotation. And my rotation will be a 4-float vector. So 4-float vector here. And using our PT num here into a random node. And the random node goes into an fit range. And I will promote the destination min and max. So call it dest min and also dest max, like so. I also need my frame count here. So I'm using my frame here. And I'm plug this into a fit range and promote my first and second input. And I'm calling it time min and time max. And let's use a multiply here, plug the time inside, and also our PT num. I give it a little bit more space. And also let's promote the third inputs to a global multiplier. So we're calling it global. Maybe increase the size here to 5. And we need a quaternium to make it 4-float. So we plug this here into our angle. And the quaternium goes into the rotate. We also need to add a constant here. A constant of 7, I guess. Pretty good now. And afterwards, we're using a random. But from 1D to input 3D vector. And the fit range afterwards. Let's only change the value from destination min to -1. And we plug this into our axis. If we move up now, play our transform pieces here. And the global value will be a 7.4 maybe. And you will instantly see there are some rotation here now. But we have to change the timing. And we will start with a time with 1 goes to 100. So a frame over 100 frames. The stuff is moving now. This is already looking pretty cool. But the destination min is also maybe, we will increase it a little bit. Maybe like this. All right. Now we will see some of the points are not moving up. The minimum value. So we can increase it here a little bit as well. And let's watch our length again with the dir. And you will see some of the points are like 0. So we don't want to have a 0 here. So we have to change the length here. So let's move it a little bit more down, like so. Now they should move up as well. Watch the result now. Now all the points are moving up. Maybe they are a little bit too fast, but this is okay for now because we will retime everything later on. And this already looking pretty cool here. So inside the camera, we only see the points floating upwards here, all the debris. And with our controller, we can easily change the seat here to a seat we really like. Yeah, this is looking cool. Maybe they are floating too high here. So we can go to our animation and just lower the value to maybe a 4 or a 3. So they are not floating that high here. And this is looking pretty cool already. And now we also want to set some rotation for our other points here. But let's first make some space here again. And we copy over this setup here again, like so. You can just select everything and hold Alt and drag it over here, so you copy the whole setup. And let's use another attribute drop again. You know it already. We plug this in here, calling it rotation PTS, and plug this in here. Now let's dive in. And I will make definitely a little bit more space again. This here up here. And we will start again with importing our points. So we're using import point attribute and a constant for our point 0. So this will be an integer, goes into the ptnum. And we need our position here again, and the distance between this point here and the position. So I drag this down here and plug this into the position. Great. And now let's fit the range here. And I will maybe lower it a little bit around the value of this here. And the ramp afterwards, ramp parameter. And this will be my ramp distance. And this will be also a spline ramp. Now let's start with our time here. So we're using the frame, going into a fit range again. And this will be this is my timing. So we will start with time min and time max. And I think I'm using a value here of 50 and the float value default of 36, like so. Let's drag it into a ramp again. And this will be my ramp animation, like so. And this also has to be a spline ramp. Make sure you also change the name if you have more than one ramp in here. And let's use a multiplier over here. Plug the animation inside. And now we also need some other stuff. So for this, I'm making a little bit more space here. I'm using my ptnum, using a random over here. So I'm using random points for the animation later on. And again, a fit range where we promote the min and max here. So I'm just calling it min and max. Let's plug this into the second input of the multiplier. I will plug in my third input and the fourth input we promote again and calling it global. That's using a quaternium at the end. And we also need our axis here. And for this, we can use a Gaussian random, like so. We plug the ptnum into the seed. In the result, we will normalize. And let's plug the normalize into the axis. At the end, we just need our rotate attribute again. So we're using bind export, calling it rot for rotation. And this has to be a 4-float vector again, like so. And let's move up and changing some values here. For ramp distance, we want to flip it. And let's add 1 point over here. Select all the handles, and we will change it to B-spline. And we want to make this here a little bit more down. For the ramp animation, we will plug this up here. And the time will be 36. This is okay. Or maybe we will increase it to maybe again 100 like the other one. And let's watch the result over here again. We also have to increase our global. And I will only change it to 1. But now you can see we get some rotation in the ground around here. It is looking pretty cool. So it's looking more like a destruction here. If you watch the result, you will see, damn, destruction. Always here and here. For the min max, we also can increase the minimum a little bit more and decrease the maximum a little bit more. Something like this. I guess this is looking fine. And we got our result here. And if the rotation of the pieces is a little bit too fast for you, you can also change the rotation max a little bit down. So the rotation is not that fast here. But this is looking cool. Now let's also add the retime here. So we're using retime. Plug this in here. And we will change it to by frame. But I want to have a controller for this. So I'm plugging this here to my controller. And just copy it with Control, Shift, and Alt, like so. So all the inputs are copied. Let's move it down here. Plug this in here. And watch the results. And we only want to change this retime over here. And the input frame range should be from 1 to 64. And let's also change the frame here. So we're starting with frame 1. And I don't want to have $f in here. So I will delete it at first. But we'll start at frame 1. And we're going to frame 36. We will set another frame here. So, and inside here we're using frame 50. Now let's go inside here. And we will drag this up here. Something like this. So it's really fast at the start and slows down over the time for the slow motion effect here. And I'm not using my ID, but my ID underscore oric, like so. And I think the rest can stay as it is for now. But we also need a time shift afterwards. And maybe I use a global control for this as well. But let's add a time shift in here. And I'm not using it like this, but in the controller, another time, I'm using an integer value again, calling it time shift, like so. There's a range from 1 to maybe 10, like so. I got 2 integers, but I only want a single integer, like so. Size of 1. Let's use a value of 4 maybe. Copy this parameter. And inside here, you go inside here and type minus. And afterwards, we're using phase relative reference. And now we got a slower start, so it's not starting at here, but after the foot's hitting the ground. And we can watch the foot over here. And the foot is hitting the ground at frame 6 maybe, so maybe we will increase the scale in the controller to maybe 5 or 6. And we also have to watch the result and not just anything else. So maybe a value of 5. But here it should start, so maybe 4 was good. So before it's not starting, and then here, after the foot hitting the ground, stuff is floating up. Now let's use another null at the end here. And we will call this animated BTS retimed. And let's clean everything up for now. So I'm using something like this here, something like this here. Can move up a little bit. Maybe I want to set my rotation to one color, so I know my rotation is always maybe something like this. My dir and length will be yellow, something like this here. It's looking good. And the rest can stay as it is. I also don't need this null over here, but the rest is looking good like this. And let's also use another transform pieces here. And again, we're using our fracture, our rest points, so we can drag the rest points over here, the fracture inside here, and we need our animated points here. We can plug this inside here, and now we got our retimed animation here, the foot. This is looking great. And with the controller, we can easily retime everything here, so the seat here, for example, and all the other stuff. Great. Now let's clean this here up as well. At here, I will also add a null, I'm calling it fracture retimed, and a null after here. And I'm calling it fracture normal speed. Now let's use our setup points here. And this will be my transform pieces. I will give it a little bit more space, like so. Let's select everything and create a box out of it. And I will make it a little bit darker here, but just the box, not the nodes. And for this big setup here, I will also make a little bit more space. Copy this here over. And I call it Animate Points. And let's also create a box out of here. So before we will start with our small debris, I will create our controller a little bit better. And for this, we will selecting our controller here. And let's also go on here, create a new paint tab, parameters for our controller, and let's also pin it. And I will make some changes on here. So let's go to edit parameter interfaces. And I will delete my retime over here. Let's create a new one. And I also go to by frame. And inside here, we will go to our time, paste this in. And this will be my retime now. Also in here, I will call it retime. And I will change the range from 1 to 100 and hitting apply. I will use a 1 value in here, go to frame 1 and hitting alt and left click on the retime. And let's go to frame 36 and let's type 50 in here. Again, alt and left click. And afterwards, we're clicking shift and left click in here to open the animation editor. Let's use a graph like this here. So it's again faster at the start and getting slower at the end. Great. Now let's copy this parameter and paste this in here. Great. Now we got the animation again. And we also want the start and end frame. And inside here, we also need ID underscore oric. So it's our original attribute again. Now let's start with an integer value on here to time. And this will be my start frame. And also in here, start frame. And this will be my end frame. Inside the start frame, let's also horizontally join to the next parameter and hitting apply. And this will be a 1, and this will be a 100. And one thing we also want to add, I will maybe change this here to selected PTS. And let's add another folder in here. And I call this points selection, hitting apply. And I will plug all the stuff inside here. Inside the selected PTS, the folder selected PTS, I will change to a tab one, also for the point selection. Great, so if we now add more folder on here, they also will be tabs, so we can also close them. And now we will start with our dir and length attribute. And for this, we're creating a new folder in here into the selected points. but this goes into the point selection in here. This also will be in tab, but also in the selected points, like so. And I will call this here animation. Now let's create another folder in here, and we will call it length, and another folder in here, and this will be called dir, and another folder called length again. But this folder, the length one, will be a simple one, and also this here will be a simple one. Or maybe a collapsible one is a little bit better. Let's make them collapsible. So if we go inside here, this is my length, and we will start with dir, and we're using a speed float vector on here for the frequency, also for the offset, and one for the amplitude, and one for the roughness, like so. Hitting apply. So we're getting our stuff in here. Now let's rename them. I will type underscore dir once to copy it, and this will be my frequency dir, and I will call this here frequency. This will be my offset dir, and this will be my offset. This will be my amplitude dir, and my amplitude, like so. And the last one is my roughness dir, and my roughness. Now we also need the values in here, so there's an easy trick as well. So we can copy parameter and paste the values in here. So we do this for the amplitude as well. Paste the value, and for the roughness. Now let's use copy parameter in the controller, and we use paste relative reference inside here. So once for the frequency, once for the offset, once for the amplitude, and the last one for the roughness. Now we can move on to the length, and we will start with our global multiplier. So we're using a float, and I will call it global underscore length. Again, copy the length in here, and I call it global mult, like so. And let's use a value from 0 to 5 maybe. I want to have the global here always a little bit with space between the other ones, so we can use an spacer in between. So let's add a spacer, and we use a value of medium. So we got some space between the global and the other stuff. We will start with our min and max value. So we're adding two floats again, like so and like so. After that, we need again our frequency, our offset, and the amplitude and roughness. So again, two floats here. And let's rename them. So this will be my min length and my min. This will be my max length and my max. This has to be my frequency length and my frequency. The next one is my offset length and my offset. And the last two are again my amplitude length and my amplitude, and also my roughness. Roughness length and roughness. Hitting apply. I will change some values in here as well. So from 0 to 1, same for the amplitude. In the min and max value, I'm using a value for min from -1 to 1, and for the max from 0 to 1. In the min, I'm also using horizontally drawn the next parameter, hitting apply. So it's looking like this, and I guess the rest can stay to this. Now let's copy over our values here. So for the global, I will paste this in here. My min goes in here, my max goes over here. The frequency I again copy with parameter and paste value. And my roughness goes inside here, and my amplitude is the value of 1. Now let's paste all of this into here. So paste relative reference, same for the min, and also for the max. So copy parameter, paste relative reference. Also need our frequency again, paste relative reference, and our offset, paste relative reference. At the end, the amplitude and the roughness. We will start with the amplitude and also the roughness. Great, now we got the length here. We can control everything. So if we want to scale it up, we can do it. If we want to change the frequency, we can do it. We can change the roughness. Maybe inside here, I also want to change some values. So maybe I'm using a value of 1 here for the amplitude and roughness. Now let's move up. And I also need to add my roughness in here. So let's copy my roughness from here and paste it inside. And now if I change my roughness, it also changes here. Right, my amplitude. Now we will need to add a new folder. So don't my length folder here, but animation folder. There will be my anim for animation. So inside here, we using this here. And we will start with our start and end frame, but maybe we can do it at the end. So we will start with our min and max value again. So we will start with our global multiplier again. So we will call it global mult and global anim. Now let's also add a spacer in between again, like so, with the height of medium. And this will be a value of 3. Now let's add the min and max. So I'm searching for my floats again, min and max, like so, hitting apply. After that, I want to add my ramp in here. So my ramp like this, hitting apply. And at the end, the integer values start and end frame, start and end frame. but I think I don't need them inside here because we got our start and end frame in the top here, and we can just copy it over to here. So we will start with this as well. So I'll copy my start frame inside here, and my end frame goes into this here. Great, now we need the min and max value. So this is my min, this is my max, calling this min underscore anim, and this is my underscore. To be my ramp anim, animation control ramp, like so. Let's use this here and paste it inside the ramp with paste relative reference. And for my anim, I use this here to my min, and my max goes into my max. Now let's use the value of the min here and paste it into the min, and the max goes into the max. I will copy this parameter in here and paste it in there. So paste relative reference again. And I also want to change some values here, so horizontally join the next parameter. So the min goes in here, and I'm using a value of 1 and -1 again for the min. And for the max, I'm using a value of 0 to 1, like so. And for the global multiplier, I also have to copy it over. So copy parameter and paste relative reference. I think I got a mistake here with our ramp. So copy parameter and paste relative reference. And now it's back in there. So we got our length, our animation, and we can now add our rotation. So I will make this smaller, add a new folder, also a tab, call it rotation, apply again. And let's go inside here. I don't need my min max value, so just my global one. So adding a float, and this will be my global rotation and my global mult again. Let's add on spacer afterwards again, falling with the height of medium. And at the end, we're using a destination min and max. So let's plug this in here. This will be my min rod and my min, and my max rod and max. Let's also use horizontally drawn to the next parameter. So I got everything inside here. This has to be a 7.4. I paste this value inside here, paste relative reference. And now let's use the min value in here, the max value in here, and I go move it back as a relative reference, like so. Also at the time, copy parameter the start frame, and also the end frame again. Right, now I got everything inside here, but I want to change the range here from -1 to 1, and from 0 to 1 for the min. Great, now we got everything in here, but we got our other points over here. And for this, we create a new folder after the selected points. Or let's collapse everything in here, and we add it in here. And this will be my other PTS, hitting apply. And I only got my rotation here, so I will just plug it over there. And I will start with my multiplier again. So I'm adding a float, calling it global rod again. This will be my global mult, to be a value of 1, parameter and paste relative reference. And we can also copy over the time, so start frame and also the end frame. Paste relative reference. Now let's add our min and max, and afterwards the ramp. So we will start with 2 floats again, one float and another one, and afterwards the ramp. For this here, I use horizontally join next parameter. Just add the name in here. So ramp control rotation, and we call it ramp control rod. Hitting apply, and now we copy over the values. So paste values and paste relative reference. And at the end, we copy over the min and max, min and the max, and I also paste in the relative reference. Great, now we got the first stuff here. I think there will be not more. And we can hitting apply. Moving over here, we got everything, the animation, the stuff. But I think inside here, we also need to add a spacer after the global multiplier. So let's add this real quick. Be moving down to the global multiplier on medium and hitting apply. Now we can use another null after the rotation, and we're calling it export PTS. And let's start with our small debris. I will paste down an object merge with our exported points here. And we want to start with creating some lines from the first frame of the point to the last frame. And for this, we're using 2 time shifts here. So time shift over here. And let's copy in our start frame inside this one. And let's paste this over. And inside here, we're using our end frame. Let's use this inside here and merge them together. So we got this points and this points. And with one add node over here, we'll give it a little bit more space. We can go to polygons, by group, by attribute, and we're typing ID oric or ID original attribute, and we're getting these lines. Now we also need some scatter points, and for this we're using our fractures from here. And again, we're pasting it into an object merge. And from the fracturing, we're using some scattering over here. I use relaxed iterations and the value of 3000 for now, but later on we will plug this into our controller and have more control over it. So let's use an attribute from pieces to get back our name attribute on these scatter points. So from here, we're using our name attribute, and we can use in mode of cycles or random, not necessary. And we need a rest attribute afterwards. Plug this in here. And for now, let's add an attribute warp and plug the lines into the second input. I will also display it, and we're diving in. We start with importing our lines, and for this, we can also maybe display them. So I'm going to here and display them as well. And let's use find attribute value. This has to be my name, and we're using the second input into the file name. And my search value will be my name attribute, so we're using bind for this, calling it name, and this has to be in string value. So my string is over here. We're using this into a primitive attribute, and this goes into the prim UV with our blue, so you can easily see it. And we again need our second output into the file node on here. So again, getting our lines in here. We are plugging this into an add node, and the add node goes into the position. Now we also need our time, and for this we again using our frame value and plugging it into a frame range. We promote the first inputs for the start and the end frame. So I'm calling it start frame, and the second one is the end frame. We're using this into another fit range, and let's reverse the destination min and max. So the destination min is the 1 and the destination max is the 0. Let's plug this into a multiplier, and this goes into my add node over here. And from here, I'm using one multiplier, like so. And we need a random value per point. So we're using random and fit range. I want the first value maybe 0.19, and this goes in here. And I promote the third input and calling it global. Let's plug the global into our UV over here. And the U coordinate maybe goes to 0.15, like so. At the end, I just need the noise. So we're using this here, using the P into a turbulent noise, using a 3D noise and simplex noise. And let's increase the frequency a little bit, using a really low value for the amplitude, maybe 0.08, and increasing the roughness a little bit to around 0.62. Let's plug this here also in the add. And if we use a end frame of 100 and increasing our global multiplier, nothing will change because we also need our fit range from the random attribute over here into this multiplier. But inside here, we also need some other things. So we're using a constant over here, using a 3 float value, plug this in here, and this in here. Inside the prim UV, we also need our position. And now we got our points and also the animation here. Now let's move up. And I also want to have a control over the jittering. And for this, we're using a point jitter in here and the value of 0.07 maybe. Let's watch the result. Maybe this is a little bit too much. So 0.04, and it's looking a little bit better. But I don't want to scatter it to the epsilon direction, so we're using a value of 0 in here. I also need an ID attribute, so we're using an attribute wrangle in here, and we type e at ID will be at ptnum, like so. So we run it over the points, so we get our ID attribute. Now let's use a time shift in here, and again we're using our start frame. Copy this parameter and paste the value in here, paste relative reference, and we're using a pointy form afterwards. And let's plug the attribute wrangle into the last input, time shift into the second input, and also in the first input. You will see the result will looking really weird now, but if we use the piece attribute ID we created, it's getting back to its original form now. The cool thing we can do now is we can delete some of the points here. For example, we're using a delete node over here, run it over the points, random, and enable delete, and we can delete some points here. But the thing why we do it like this is we want to delete the points that are near to the foot. So if we visualize our foot here, and we can copy it over, so paste it in here, you will see if we start from 0, some of the points are down under the foot, and we don't want this. And for this, we can easily, using a color node in here, and make the foot black. And afterwards, we're using an attribute transfer again, and copy over the color to the points on the still frame. So CD in here, and the condition of 0.015 maybe, not on the primitives, but on the points, like so. Now you see some of the points near the foot are black. We can also visualize the foot and we can blast them out. So blast, run the blast over the points, and we're calling it at TD will be 0. So with this, all the points that are 0 will be getting deleted. So it doesn't look like that the debris is coming out of the foot and it doesn't glitch inside there. Now we also need a p-scale, but before, let's add a null after here. And we're calling it getter debris PTS. And let's paste this over here into an object merge. So we get only the points here, and we can use and copy the points afterwards, plug this in here, and a sphere inside the second input. You will see they are way too big, so we need a p-scale. We're using an attribute randomize for this, plug this inside, calling it p-scale, and inside the values, we're using a one-dimensional value and a custom ramp. I'm using a value of 0.5 and maybe 1.1. And let's use a graph like this here and a global scale of 0.05 maybe, like so. This is way too big. So 0.005 maybe, and this is looking way better. Because we did the ramp like this, we got most of them really small, but just some of them are really big now, like so. And this is looking really cool. We can maybe also increase this here a little bit, like so. This is great. The next thing we want to add is the rotation. And for this, we're using a value of 1 in here, 0.3 in the X and Z direction, so we can better see the rotation. We create another attribute warp after the p-scale, and we're calling it also rotation, and diving in. Also make sure you see the visualizer, so it's a better and easier way to view the result. Inside here, we're starting with our ptnum using a random value and a fit range afterwards, and we promote the destination min and max. So this will be my min, and this will be my max. Let's plug this into a multiply, and I want to multiply it with the time, so we're using the frame inside an fit range again, and we promote the first and the second input, the start and the end frame. So this is the start frame, and this has to be my end frame, like so. Great, let's plug this into the multiplier, and the third input we will promote again, and we're calling it global, like so. Let's plug the multiply into an add node over here, and an quaternium after that, and this goes into my angle. If we're using our ptnum into the adds, so we have an offset for each of the primitives, we can display it with a bind export, calling it rotation, and this has to be in 4-float vector. Now you instantly see the points are getting rotated, and if we go up and using a global multiplier of around 10 and an end frame like 100 and a start frame of 1 and a min-max value of maybe like this here, you will see the stuff is rotating, but we don't have an axis yet. So for this, we're using again our ptnum into an add constant, using a value of 7 or 6. I guess I'm using a value of 7, going into a Gaussian random, and we normalize the result. Let's plug this into our axis, and this is looking way better now. Can maybe increase the global to 14, like so. And this is looking cool. One problem we have is that in the start frame, the debris are visible even in the fracturing here. Let's display our animation, so the retime speed here, like so. And let's also copy over our retime. So we copy this over here, plug this inside. But you will instantly notice after it's floating up, the timing is right, but in the start it's visible and we don't need this. And for this, we can animate our p-scale by calling this here p-scale multiply. And we're using an attribute warp over here, place it in here, calling it p-scale diving in. And we're starting with our frame again, plugging it into a fit range, using a value from 1 to 15. And this goes into our bind export. And this will be my p-scale. With this, over the first 15 frames, from 0 to 1. And if we go into the p-scale multiply, we can go to set value and using a multiply. Now, after frame 6, still not applying because why they are not visible here. Maybe I need to increase this here now, but I shouldn't because this was right. My points are here. My debris are not visible. Let's watch the geometry spreadsheet to see what's happening. This result here, and we're searching for the p-scale. And the p-scale is 0. And the problem is that I wrongly named the name here. So I'm using p-scale, and now it's visible again. So let's watch the result. So after frame 6, stuff getting visible and growing a little bit, and then they're floating up. Also rotate. Let's also watch it in the camera. Yeah, looking good. But let's create the debris here. So for this, we again using an sphere over here using polygons and a frequency of 10. I'm using an amount node afterwards. I will only display this here, maybe using an amplitude of 0.15. I think an element size of 1 is good, but I also want to remesh it afterwards. So with a value of 0.05 maybe, looking good. And let's recreate the normals. And we also need an UV here, so we're using an auto UV. I think this is good. We can also display it with this button here. And let's watch it in here. We can change it up a little bit. Doesn't have to be perfect. So maybe something like this, or maybe this. Yeah, this is looking good. And we're using an UV transform like this. And let's lower the scale to around 0.1 for each axis. Plug this into a merge over here. Line this up a little bit. And I will copy it over with holding Alt. Inside the sphere, I'm using a value of 1.1. Inside the mountain, I'm using another offset. And maybe also another roughness. I'm using a value of 0.3 here. Maybe also an amplitude of 0.17. Plug this inside here as well. The result also looks good. And we're using another debris here. And let's change some values again. So I'm using a scale of 0.9. Another offset again. And maybe in higher roughness, so 0.45. Or 0.42 maybe. I guess 3.45 is a little bit better. Yeah, this is looking good. Let's plug this also inside here. And we're using an connectivity node here. So we can say how much variance we have. And we want to name the attribute variant as well. And we run it over the primitives. And if we go to our primitive tab here, we will see we got from 0 to 2. So we got 3 different variants. Let's plug this into a null in here. We're calling it debris. But we also need a name on here. So we're using an attribute wrangle for this. And I'm calling it s@name will be, and I'm calling it debris underscore plus I will use my variant attribute, so add variant, and this will be itoa and run over the primitives. So we got our debris 0 to 2, looking good. Let's call it name. I will copy the debris as well and paste it into an object merge over here. Inside the copy to points, we're using pack and instance, these attribute, calling it variant. And let's plug this inside. Let's watch the results. And this is looking wrong. Something is wrong because I don't have a variant attribute on the points here. And for this, you can use an attribute from pieces, like so. After the rotation, I plug this in here, calling it variant. And let's use our merge debris and plug this in here. Now we got our variant attribute here. And I maybe also want some random colors. And for this, I'm using another attribute warp here on the points, calling it CD, diving in. And for my ptnum, I'm using a random value and fit range. And let's plug this into the CD. Let's move up and we can clean up everything. So maybe like so, pressing L to line them up. This is looking good. This is also looking good. And we can use my transform pieces here, calling it small debris. Plug everything inside here into a box. And I will make the box with pressing C to another color. But one thing I also want to add is plugging the debris into our controller. And let's do this. So for this, we're going to our controller here. And we're using edit parameter interfaces again. Let's close the selected point and the other points because we want to add another tab calling debris or just debris. We're going to our debris tab. We will start with our amount. So we're using a float value in here, calling this amount and amount debris like so. For the range, I'm using a value of 0 to 5000 maybe. Now let's type 3000 in here, copy parameter and paste relative reference. Right. The next thing we want to add is our start and end frame in here. So we can again copy the parameter, paste relative reference, and the same goes for the end frame. I think the global multiplier we don't change here, but I want to add my jittering in here. So in the debris, we call this here spread, also this here, but this will be my spread underscore debris. And it also will have a value from 0 to 0.2 maybe. Let's copy this value over here, copy this parameter, 0.04, and paste the relative reference inside here. I also want to add my spread. So for this, again, we're using another float. We're calling it spread delete around foot, like so. And this will be my delete debris. Hitting apply, I'm using a value again of 0 and maybe 0.1. Let's copy over this value here and hitting copy parameter and paste relative reference. I maybe also want to add my p-scale. So for this, I'm using another spacer in between. spacer on medium, like so. And we will start with our global P-scale. So this will be my global, this will be my min and my max. And I also need my ramp, so like this. Let's call it global P-scale, P-scale Debri. This will be my P-scale min Debri. This will be just my min P-scale. And this will be my max P-scale and P-scale max Debri. And the last one is my ramp. So ramp P-scale, ramp P-scale. This will be my P-scale ramp, like so. And I will paste over the value of the ramp to here, paste value, and now I can copy this value and paste the relative reference inside here. Same goes for the min and max. My min P-scale is 0.5 and my max value is 1.1 and my global scale is 0.005. I also want to change the value in here. So I'm using a value of 0.03 maybe. I guess this is enough. Yeah, it's looking good. Maybe even smaller. So maybe 0.002. Yeah, this is looking good. Now let's paste it over, copy parameter, and paste relative reference in here. And same goes for the min and max value. So for my min value and also for my max value. Now this is inside. I also need to add my rotation here. So I think maybe I will do a folder in here inside the Debri. Let's add a folder, calling it P-scale. Now let's plug all the P-scale stuff in here. And also the spacer behind the global P-scale, hitting apply, looking like this. And I also need my rotation. So again, a new folder, calling it rotation. And for my rotation, I can copy over my start and end frame again. So paste relative reference for both of them. And I need my float for the multiplier. Make this smaller here, everything. I only need my Debri. This will be my global mult and global mult Debri rotation. Add in spacer afterwards, again with a medium height. And we need also our min and max value again. So let's plug two floats inside here, calling it min and min rod Debri. And this will be my max and also max rod Debri. I also want to change the values in here. So the range goes from 0 to 1. And for the min goes from -1 to 1. And the global multiplier maybe goes from 0 to 20. And inside the min, I also hit horizontally join to the next parameter. And not to 10, but to 1, like so. And now let's copy over the values. So my min and my max and my global. And I will paste my relative reference inside here. And if we watch this together with our fracture retime, so you can hover over this and holding Control and Shift and paste it. So you can see both at the same time. This, let's watch it to the camera. And we can easily go to our selected points, point selection, and change the seed. So it automatically adjusts everything here. We can also change the max points here to maybe 0.9, so it's less, so it's more debris, or maybe to 0.4, so they are less, maybe 0.6, so they are just a few. We can also go to our animation and decrease the global length to a range of 0.3 maybe, but they're not floating this high, or maybe a little bit higher. We also have control over the animation, the rotation, the other points, the cracks here around. So we can also say we don't want them, or we want them bigger and have control over this. And for the debris, we also can say we want less debris stuff, so maybe just 1,000. We can also spread them a little bit more, or even less. We can also spread more around the foot, or even less. And we can make them rotate faster and slower. But I think a value of 3,000 was pretty good. Or maybe 2,500 is also good. Like so. Looking great. But I think I will decrease the P-scale even further. 0.3 maybe. And yeah, this is looking good. Let's not display this here anymore. And we can move on. So now that we got our small debris here, we also need some smoke here. And we will start with our normal speed debris here. Let's use this here and paste it into an object merge over here. And we will plug this into a debris source. Now let's visualize it over here. And we maybe want to increase some values here. So maybe a value of 300,000. We also maybe want a lower distance threshold, like so. Let's use a grayscale ramp and invert it, like so. We also need a rest position here. And I maybe will increase my cache memory. And I think I don't use a time span, but a frame duration. And let's use my end frame here. So we're getting up to our controller. Let's use the end frame here, copy parameter, and paste it in here. So paste relative reference. So I see we don't have a velocity on here, so we also need to add it. And for this, I go to my transform pieces, use a rail node over here, and use compute velocity again. Let's plug this into the middle input here. And now we got our velocity here. Let's move back, and we're using an attribute warp here to create some density also. Let's dive inside. And we need our rest and also our h attribute here. For the h, we're using a ramp. So we're typing ramp parameter and place it down. Let's plug a multiply afterwards. And I will visualize it with my CD, like so. Let's move back up. And inside here, we don't need a color ramp, but a spline ramp. And let's increase it like this. We're getting back in. And let's use our rest into an turbulent noise here. We want to plug this not into the amplitude, but into the position. Let's increase the frequency to around the value 0.97 maybe. And I want to use a simplex noise. Yeah, looking good. Let's plug this into a fit range. So I use a source value of minus 0.1 and a source max of a value of 0.3 maybe. Let's plug this into the second input of the multiplier. And yeah, that's looking pretty good. Now let's use bind export afterwards between the multiply and the geometry output for our visualizer. And we will call it density. Let's move back up. And one thing we want to change is the scale of this, because a smoke simulation like this on a scale like this will mostly look not good. So that's why we will scale it up for the simulation by value of 5 in this example. And after the simulation, we scale it back down to the original output. So let's use a transform using a value of 5. So it's pretty big here. And we will do it multiple times. So let's use a controller for this, a little one. So inside here, I will use a load value and also another one. So this will be my scale, apply. And I think I will call this here my voxel scale, like so. And I'm just using a value of 0 to maybe 0.1, hitting apply. Let's increase this here to a value of 5, and the voxel scale will be a value of 0.01. I will copy this parameter and paste it down here, paste relative reference, and yeah, this is looking good. Now we also want to not only have smoke that's following the debris, but also a little shockwave. And for this, we're using an add over here, and we're using an attribute adjust float, like so, but not on the p scale, but on the density. And inside here in the add node, we need to have 1 point here, like so. Inside the attribute adjust float, we don't want to use an operation of add, but of set always, and not a constant, but a noise, like so. I also don't want to have a min and max, but a middle range length. And the middle value will be a value of 1, and the range length will be a value of 0.25 maybe. And the rest can stay as it is. And we're using a pyro burst source. Let's plug this inside. And it's looking like this. We don't want an explosion, but a shockwave. So now we got something like this. Looking pretty okay now. But let's change some values here. We will start with our animation, because we want a start frame of 3 and the duration of 15 maybe. Looking pretty good. Maybe value of 4. We can also drag down our foot from here. Let's visualize this here really quick. Maybe using a start frame of 5. Yeah, looking good. So here's the explosion then. And now let's get back to the burst shape. And I will lower the initial size to around 0.45. A start spread angle of around 77 maybe. And let's also give it a little spread of around 17. So it's getting a little bit bigger here. And we also want to add a noise here. So it's a little bit more random. Now let's use an amplitude of 5. Size of 0.6 maybe. And a really high roughness here. And it is looking pretty cool. I also want to add a velocity noise. So we're using a velocity noise, an amplitude of 1.1 maybe. Let's also lower the size a little bit. And we want to display our noise here. Looking good. So without the velocity noise, it's looking really straight. And with this, we got a cool noise in here as well. Now let's also give it a little bit more points. So we're using a trail depth of 0.9 and a point separation of 0.04. And we're getting a really high value of the velocity at the start, but maybe we don't have to clamp it. But let's move on at first. This will be a problem later on. But now let's use an attribute delete over here. And we don't need our p-scale, so just delete this here. And I will use a null afterwards, calling it shockwave, and I will make it blue. And I will use another null over here and calling it debris source TTS, like so. Also make it blue. And I also need my scale over here, so I can plug this inside here and also got the scale. But one thing you'll see, my burst doesn't start at the foot here. So for this, we can grab our freeze foot from here, plug this down into an object merge, and let's use a match size after the add. I don't want to change my epsilon value, so I'm using none here. And let's plug the foot into the second input. And now it's lining up with my other source here. But maybe I want to use the transform above the pyro source, like so. But it doesn't spread so much here. Maybe you can also visualize the velocity again. Do we also have the problem if we start one frame earlier, maybe? Let's visualize it. So we're going to frame 4. And here this is also the problem. So we can use a value like this, using a switch if here. And inside the expression, we're using $f will be bigger than 4. And we want to use all conditions are false. So after frame 4, we got this here. But before frame 5, we doesn't got anything here. Now let's move this here down. And I need both of them into an object merge. So I got everything here into an object merge. And let's merge them together. And afterwards, we need a point velocity here to add some noise. So inside here, we're using keep incoming. And let's add the color noise. And I will lower the scale to around 0.4. Pulse duration of 1.1 maybe. Let's also lower the swirl size to 0.26 maybe. And I think the rest can stay to this. Now we also want to use a volume rasterize attribute, but I don't plug it in yet. So we can use our voxel size from our controller here, using copy parameter and paste it in here, paste relative reference. The particle scale will be 0.02 maybe. And the attributes I'm using is V. So now we can plug it in and visualize it. And this is how it looks like. Now let's use a null after here. We're calling it velocity. And we're using the same setup from here. Paste it over. And again, we're using a volume rasterize attribute. Again, using inside the voxel size, paste relative reference. So we got our parameter here. And the rest we will also change again to around 0.02. Will be my density. And again, the rest can stay to this. And now we plug it in. Let's use another null here. We're calling it dense source. And we're using a merge again. So I'm using both of them here. Plug them inside here like this. One thing we also need is a collision object. And for this, I again need my transform and my debris source. And let's use an VDB from polygons afterwards. Use a value of 0.005. Plug this inside. This is looking pretty good. And we can use a file cache here. I will call the file cache SDF cache. After the geo, I will type $$s, and this will be my SDF. Now we can hit save to disk. And if it's loaded, we can use a file afterwards and load in our SDF here. Now I also need another null afterwards, and I'm calling it SDF, and I will make it blue again. So we got our first outputs in here, our second outputs in here. I will also make them blue. Now we can add the pyro solver here, and let's add some changes in here. So in the voxel size, we paste in again our voxel size, so copy parameter, and paste it down here as a relative reference. In the sourcing, we don't need our temperature or the flame, and I will maybe lower the velocity to around 0.2. In the field step, I don't need my dissipation and the flame. For the shape, I want to use some disturbance and turbulence. So let's use a disturbance of 15. And let's also use the control field with a value of 0.05 maybe, same as for the threshold field. And inside the turbulence, I'm using a value of 0.006 and a swirl size of 0.7. And the threshold field will not be a temperature because we don't have some, but the density. And I think the rest can stay to this. Now let's also go to advanced, to sparse solve. And inside here, we're using new occupied or decoupled, and we don't want this here. And I think now we can add it to here. Let's move to frame 1 before and visualize frame 10 maybe. And yeah, this is looking pretty cool. But we don't have our collision in here yet. So for this, we need our SDF. Let's go inside the pyro solver. And by the force output, we're using a volume source. We use collision over here. And let's place our SDF into the subpath. And the name of the collision is, you can find in the SDF, under the primitives, there's called surface. So we know we need to type in here surface, like so. Let's plug this inside. We can again go to frame 1 again, and afterwards to frame 10 maybe. And I also want to use my time step. Now we can move back up. And the problem we will have now is we got this viewport bug here where you can see the collision still, even if you're not in the Pyro solver anymore. So you can go to labs if you have installed labs and restart the viewport like so. So you don't see it anymore. Or you can also go to new paint tab, viewers and scene view, and it's also not visible anymore. Now let's maybe move to frame 13. And now we also got our collision here, and this is looking really cool. Inside the camera we don't see anything because it's so scaled up, but we can change it real quick. So let's use a transform just for now. And we want to use our scale. We can use the scale from here, the parameter, or just copy it out again from here. So copy parameter. And after that one, we're using a slash. And let's paste in the relative reference. So we divide it by this value. Now it's getting back down here. And visualize like this. And we also need an pyro bake volume. And we're using a density scale of 13 maybe. And let's also change the color here. And I think something like this is looking really good. Great. And now we can cache it out. So for this, after the Pyro solver, we're using again a file cache node. And let's call it /$s. And inside here, I will call it Debri volume smoke, like so. And this will be my smoke debris cache. I will plug this into the Pyro solver. And let's cache it out. So now that the cache is done, we can use on file node afterwards. And let's load in the cache here, like so. And afterwards, we can finally use the transform here, the pyrobake volume, but we also need our retime. And for this, I press P to not visualize my parameters here. We can go to our animated points and we use the retime and the time shift and copy it down. Let's plug this in here. But one thing we need to change on the retime, we need to go to volumes and the blend mode needs to be by voxel position and not transform only. Now let's use the pyrobake volume afterwards. Looking good. The last thing we need is a name for the volume, because now the volume doesn't have a name, and inside stage it will just called volume_0. So for this we're using an attribute wrangle. This can be run over the points, and I will call it use the volume path, like so. Will be, and I'm calling it debris smoke. And at the end I'm just placing a null, calling it debris smoke. And let's clean the end up a little bit more. So I select all the nodes here, pressing L to line them up. And also for this here, like so. The rest is pretty clean. Maybe I want to move my controller over here, or maybe on the left side here. Now let's add the small debris text to this side and also call it smoke debris, a little bit larger, smaller, like so. And I will select everything in here and create a box. I will move the box up a little bit to here and make the box brownish color. Now that we got our smoke here, we can move on and create our dust particles. And this is a pretty easy and simple setup. We first will create the camera view as a geo. And inside the camera view, then we will scatter some points. And on the points, we will scatter some geometry to have the dust particles. And for the movement, we use a pop network to give it a little bit of noisy movement. To create the camera view, we need a box in here. And I will increase the center to 0.5 and also here 0.5. Now let's visualize the box. All right. One thing we need for the camera is an attribute wrangle to import it. So we typing string cam will be channel string, and I will also call it cam, like so. And we can hit this button to create this parameter. To import our cam now from the obj level, we have to type obj. And after that, our camera, in my case, it's the camera here. So let's plug this inside. So we got the camera. And now we want to change the P of the cube. So add P will be from NDC, and I have my cam we created here, and also my add P. Now let's visualize it, and you will see it has a really low value here. And the problem is that our camera is divided by 100 because of this value. So we can go up, and 100 in here is 1 meter in the original one, and something went wrong, and because of the center here. So we have to copy this parameter, and for example, if we type -50, you will see it's correctly here. So we always have to have the half of this value here, but also inverted. So let's paste the value in here, paste relative reference, divided by 2, and also a minus before. Now if we change up the value here, for example to 200, you will see everything is working now. Great. Now to scatter the points, we can create a scatter node. But the problem with the dust particles here is there are no points inside the cube here, because it's scattered on the surface. And to scatter them inside, we can use PDB from polygons here. and not using a surface but a fog. Now you will see they are also inside. And let's use not relaxed iterations here to make it more random. But you will also notice that the points are jittering here at the movement of the camera. So we have to freeze the camera. And for this, we're using a time shift after the attribute wrangle. And let's use the start frame from our controller. And we will paste it inside the time shift frame here. Paste relative reference. And now it's a still frame. We can watch it through the camera as well. And if you see the left and right side, for example, has two left points, you can increase the value here to around 0.2. Maybe also the height to 1.1. It's looking way better. And we can start with creating the movement of the points. And for this, we're using a pop network here. And let's dive inside. The problem you will see after we switching it from emission type to all points, that each frame they are getting points generated, and we don't want this. So for example, if we're using a gravity force over here, you will see that they will be constantly emitting some points, and we only want the points on the first frame. And for this, we can use a switch if node. And in the expression, we type if the frame is larger than 1, we don't want this. So on frame 1, we have it, and afterwards, they're getting deleted, and only the first points getting emitted in the pop network. But we don't want gravity, but pop wind to add some noise on the movement here. And I think I'm using a value of 0.15 for the amplitude and a swirl size of 2. Watch the result. But yeah, that's looking really awkward. And we want to create an offset on each of the points here. And for this, we're using the VFX expression. And let's type offset point x will be our add ID divided by 5. And also create a custom air resistant. So air resist will be multiplied with a fit function, fit01. And I want a random number from my add ID. And let's fit it into 0.5 and 1, like so. And let's watch the result again. And now we got a better movement of the points here. I think I will use a file cache afterwards. Cache it out once. I will call it dust PTS. Also in here, I will type $OS. And also in here, I will type dust PTS, like so. Let's plug the pop network inside and save it to disk. And after the file cache, I'm using a file node and read it out. Right here. Great. Now I got my particles here and also the movement of the camera. I will also hide my objects here. Now that we got everything, we can also use a rail node here and use compute velocity here. But you will see on the first frame it's not working because we also have to change the start frame to 0. Also inside here we're using start frame of 0. Let's cache it out again. Reload geometry, and now it's working. And also visualize our vector here. I will increase it to 30. There are our movements, the velocity. Now let's maybe also use the retime and the time shift here. Plug this down here, plug this inside. From the start it's moving a little bit faster and afterwards it's getting really slow. But you will see now that we get 2 points here, always from the same point. This is because our switch if is starting at frame 1, but we also have to decrease it to frame 0. And if we cache it again, now it should work properly. Yeah, now it's working good. Let's visualize this here. Yeah, this is looking good. Next thing we want to create is our dust geo. And for this we're using some spheres. I run it over the polygon here. And I'm using a frequency of 17. Let's visualize the result. And I will use a mountain node afterwards. Maybe an amplitude of 3 and an element size of 0.5. That's looking good. Let's create 3 of them. So just change the offset here. And I will create the merge and the connectivity afterwards. And the connectivity, I will run it over the primitives. And this will be my variant attribute. At the end, I will also add a null and call it variant, like so. We'll also clean it up a little bit. Maybe move this here a little bit to the right. And we can drag and drop this to here into an object merge. And I want to have my variant attribute also on the points. And for this, we can use an attribute from pieces, calling the piece attribute variant. And let's plug this inside, but also run it over random, like so. Now in here, we got our variant, like here, looking good. Maybe we also want to delete some of the attributes, so attribute delete non-selected on the points. And I want to keep my velocity. I want to keep my ID. I want to keep my variant. And I think that's it for now. So it's a little bit less information on here. But we also can create our p-scale. Let's add an attribute randomize, calling it p-scale, run it in one dimension, and I will use a custom ramp over here with a fit value, maybe of 0.1 and 0.3. And let's decrease it to 0.004. And if I create a null afterwards, I can call it scatter dust PTS. And let's create an object merge for both of the outputs here on the right side. And we can plug them into an copy to points to visualize the result. So copy to points. This is my geo. That goes in the first input. And before I will plug in my points, I will pack an instance and also call the piece attribute variant. Great. Now let's plug this inside and let's watch it through the camera. These are our dust particles here now. Maybe I also can increase the size here a little bit different. So inside here, I'm using a value of maybe 2 to make them a little bit different. 2.5. Yeah, these are our dust particles. Great. We don't need rotation on the particles because they are so small they are just not visually visible inside there, but have a nice flare in the rendering later on. Now let's clean everything a little bit up. Move this down over here. This is my visualizer. And I will drag and drop this to here. And this will be my dust. And let's select everything and create another box out of it. For the color, I will use a darker gray again. Maybe not this one, but maybe also maybe use this one here. So now we can move on to our last part, and this will be our cloth simulation. And for this, we will start with importing our cloth. I will import it in here. So let's create a file node, and I will import my cloth here. But I also want to separate my leg here. So let's select the leg. I don't want to select my edges, but my primitives. So let's select this here and also this here with a double click. Now we can hit enter and use delete non-selected. So we only got the one leg here. I also need my UVs on the vertices because now my UVs are on the points here. You can see in the geometry spreadsheet. And let's use attribute promote for this. From the point to the vertices on my UVs. Now let's also fuse some points together to clean it up. And at the end, we're creating a null and calling it cloth like so. I will also select my ground name and paste it over here. And I will call it cloth, select everything and create the box in here. Let's also make the box green. And now just select the cloth null here. And we can paste it down here into an object merge. I don't want to visualize my UVs anymore. And let's plug this here into an vellum configure cloth. And I want to change my bend stiffness to a value like this here. And also the density to around 0.03. And now let's create the attach here. So for this, we're using vellum constraint. And we move up here. We want to change the constraint type here from distance along edges to attach to geometry. And before we can attach them, we need our foot here. And for this, let's move up to our character, select the foot, and we will paste it down. But we also need the leg here, so let's select the other foot. But I don't want the shoe here, so just deselect it. And for this, we can go to Alembic path and only deselect the shoe here, hitting enter. So we only got the leg and the foot again. Now let's copy it and we will paste it down here into an object merge. And from here, we're using a time shift and we're using a value of -50 here, like so. So we start from the straight leg here. So it's first, we got this simulation here. And afterwards, we got the stamp on the ground. Now let's also create a polyfill for the hole here. And for this, we create a polyfill after the time shift. I will run it over single polygons. But I also want to use another time shift over here and only use frame 1, like so. Let's use a point deform afterwards. If we plug this in here, and this goes in here, and the last one goes in this one, we got the animated foot with the polyfill here. But we want to make this to an VDB and convert it back. So let's use a VDB from polygons and maybe use a value of 0.05 or maybe even lower, like so. And then convert VDB afterwards to convert it back to polygons, like so. Maybe I also want to give it some adaptivity. Guess I'm using a value of 0.07, like so. Looking good. And now let's plug this into the cloth simulation here. Into the vellum constraints, we can dive in. And the group type will be edges. And I will select the top part here. And also the part where the knee is from behind, like so. Maybe a little bit lower, something like this. So we connect the pants here Now let's create a border for the bottom parts here, for this edge here. And we use a group for this. I run it over the edges and just select with one double click this edge here. So we can select the outer edge and we will hit enter. And let's call it border, like so. Now we can place this into a vellum pack. So vellum pack like so. Let's plug this inside. And I also need my leg again. So this will be my null. So leg, and I will make it blue. Now we can also plug this into a vellum unpack. In between, we're using a merge. So we can also create some other simulations afterwards and plug other vellum packs inside here. And after the vellum pack, we're using a vellum stitch to stitch the point. And let's use closest location on primitives. And this will be later on my point group, but we will let the settings like this for now. After this, we're using a vellum solver. And for the third input, we're using our leg here. So let's place it down into an object merge. Let's go to the solver. And inside here, I will use global substeps. I will use a value of 8, like so. Also 200 constraint iterations. Inside the forces, we will lower the static threshold and also set the dynamic scale to 0. And I will increase my cache memory. And the rest can set it is for now. Now let's also give it some forces. So we will dive in. We're using a pop wind in here. Plug this in the force tab. And I will use an amplitude of 1 and maybe increase the air resistance a little bit to a value of 1.15. Let's move back up and we will move to around frame 55 for now. Now let's visualize the results. So the footstep is over here, damping down, maybe some more frames, but this is looking pretty cool. So, but now we also want to have some strains here on the edges. And for this, we basically use our group here and our cloth. Let's plug this inside. And we got the viewport bug here, but we can easily go to labs, reset viewport. We got the normal viewport back. And now we want to create some curve out of the group here. And for this, there's a node called edge group to curve. Now let's select the curve. We use border here and we can scatter some points on them. So let's use a scatter node over here. And we will start with a value of 2500 maybe. We don't want relaxed iterations. So it's a little bit more random. And we also have the normals to look down. So let's create some normals. We're using an edgewood wrangle for this. So edgewood wrangle. And this will be my v at n will be set to 0, 1, and 0. And I also want to have a different p-scale. So we're using edgewood randomize, calling it p-scale, using one dimension and also a custom ramp. Let's maybe use a ramp like this here. I also want some other values. So my lowest value is 0.1. And let's use a copy to points, plug this inside, and we need a line on -1 on the z-axis and a length of 0.02 maybe. Let's watch the result. Maybe it's already looking good. And yeah, it's looking really good already. But for a simulation, there are 2 less points on here. So let's use a resample. The value of 0.002, something like this. Looking a little bit better. Maybe even lower, 0.001. Yeah, like this. Now let's also pin each of the highest point of each line here. And for this, we can use a group expression. That here we want to run it over the points. And let's type vertex from index, like so. And inside brackets, we want a 0 on the vertex number will be 0, like so. Now we got all the points here on the top part. And we don't want to simulate them as cloth, but as hair. So we're using a vellum constraint hair, like so. And inside the hair, we're moving down to our bend stiffness and also lower it, like so. And we also maybe want to lower the damping ratio to around 0.02. I think the rest can stay as it is. And we can use a vellum pack over here. Let's also plug this into the merge. And inside the vellum stitch, we can use our group 1 here. We maybe want to rename it. So this will be my pin group. So I will call this pin. And this will run over the edges. And this will be my border group. Now let's go to the vellum solver and reset the simulation. Now let's watch the result here. And we maybe want to make some changes here because this is way too hard inside here. So let's move up here to the constraints of the attach. And we don't want this here, but maybe here and also on the knee maybe, something like this. But let's also move it up a little bit. So for this, we're using a transform. And I also maybe want to scale it up a little bit. But before, let's center the pivot translation. So let's use $CX, $C epsilon, and $CZ, like so. Now if we want to move it, you can see the pivot is in the middle of the cloth. Slightly increase the stance here, and I will move it up a little bit to 0.05, and also a little bit to the right to around 0.02. Great. And I think I will maybe just plug this here inside the border as well. So, and let's move back to here, going into the Vellum solver, and let's watch the result at frame 58 again. Now let's watch the result. And we got a weird bug over here. And to fix that, we need to just change some values over here, changing some values in the attachment, and maybe also here in the Vellum cloth. So, and I think, yeah, I will change some values in the attachment as well. So maybe something like this here. Good. And I maybe also want to change the count here to around 2200. Let's move this a little bit down. And let's watch the result at frame, see the first frame again. And let's move up to frame 58 again. Let's watch the result again. Let's watch it also through the camera here. I think we can delete this frame here. Yeah, let's cache it out for now. So we're using on file cache. And inside here, I will type $S. This will be my pants cache. And this will be my pants. Great. Now let's cache it out. After we are done with the file cache, we can use a file node again, place it down, and we can load in our pants here. Now we can retime it. So we're using a time shift over here and using a value of +50. So the movement down here is on the frame. And let's also use retime. And at frame 10, we're using the speed. I will create a keyframe. And let's move forward to around frame 29. And let's lower it to a value of 0.1 maybe. So here it's really slow then. Now we also want to create a curve in here. So we're hitting shift and left click the speed. And at the start we want to have it fast, and afterwards it's getting slowed down. Now let's watch it through the camera here. We're having this issue here. So we maybe just want to import it from here. So frame 6. Let's use a switch if node. And let's type if $f will be bigger than 5. All conditions are false. So before frame 5, there's nothing. And after frame 5, it's getting imported. Now let's watch it together with our lag. So we're using a merge over here. Let's grab our lag from here. We will paste it down, plug this inside. And this is looking okay, but we can maybe move it a little bit down. So we're using a transform and using a value of -0.05 or 0.7, like so. And this is looking pretty cool. So we can use it like this. Let's delete this here. And we're using another null afterwards. And this will be my pants. Let's clean this here a little bit up. So I will select the nodes here, pressing L to line them up again. Something like this, and also over here. Yeah, looking good. Now let's use the dust name. And this will be my pants. Select everything and create another box in here. Let's move this over here. And maybe I want to use another color, maybe purple. Looking good. And we can move on to the preparation for stage. For this, we will start with our fracture retime here. So let's copy it over. I will copy it down here into an object merge. And on the primitives, there will be a name attribute, but we also need a new name for this. So we give it a name, and I will call it destruction, like so. But we need to spare our name attribute into another attribute in here. So let's use an attribute wrangle for this, and we will call it as@deform. Will be as@name, like so. So if we go to our deform attribute on the primitives, we will see now we got our pieces in here. And after this, we're getting also a new name attribute. I also need my deform attribute on the point and not on the primitives. So for this, we're using an attribute promote. And from the primitives to the points, we will be using my deform attribute. Now we want to make this more low res. And for this, we can use in poly reduce. We maybe want to use a value of 20. So we just keep 20%. Let's visualize it. And it's looking like this. And because it's animated, we don't want to calculate it every time once again. And for this, there's a really cool trick we already know. We can use a time shift in here. And we just want to use frame 1, like so. We can use the technique with the point deform and plug this into the first input. This goes into the second input. From the attribute promote, we plug this into the third input. Now it will look really ugly here, but that's why we created our deform attribute here. So we can plug this inside here, calling it deform. And inside the poly reduce, we're moving down here, make reduction sensitive to attribute. And this will be also my deform inside here. Now it will load once, and after this, it's working fine here, as you can see. Now we got the low-res version of this, and we can move on. This will be our procedural for the stage level. So we need to give it a USD purpose, and this will be my proxy. So let's add an attribute wrangle over here. I will call it as add USD purpose, and this will be my proxy, and we run it over the primitives. I also want to give it another color. This will be a sand ground, so maybe a color like this here, something like this. And from our name, we will plug this over here into another attribute wrangle. Also run it over the primitives. And let's copy the USD purpose inside there. And this will not be my proxy, but my render geo. Now we can merge them together. Plug this in here and this in here. And before the attribute wrangle here, we maybe can see if there are some points that are not connected to the geo. So we can use a clean node on here and just remove unused points. We can select this here and this here, but there are no points anymore, so we can delete it. And if we use another attribute wrangle afterwards, we can define the path here. So we're calling it as add path will be my as add name plus a slash in between plus my as add USD purpose. Now if we run it over the primitives and move to my path attribute now, you can see it's called destruction/render, and down here also destruction/proxy. At the end we're using an USD file export, and under the export we want to change it up a little bit. So I don't want to plug this into my geo, but into my USD folder. And I want to call it /$s/$s. So inside the USD folder, there's another folder called same as my USD export. And this will be my destruction. Let's maybe make it red so we know it's an export. And this will be has a frame range of 36 frames, because after the 36 frames, the animation will stop. Or maybe it's a little bit longer, maybe to frame 40 here. And we're hitting save to disk. Now we prepared our destruction scene, and let's copy the fracture from here, paste it down, and this will be my destruction, like so. And let's grab the next thing, and I think I will use my pans for now. Let's plug this next to the destruction here into an object merge again. And the first thing we want to do is we want to separate our strains from the pans here. And for this, we can use multiple ways. For example, we could go up here, and after the group and after the resample, we can add an attribute called pans, for example, and use the pans attribute 1 in here and the 0 in here. So afterwards, we can split it up. But we use a measure node for this here. So we use an connectivity node on the primitives. So we're having a class attribute here. Afterwards, we're using a measure node. We want to measure the parameter length and per piece. And the piece attribute is my class attribute. Now let's add a split node in here. And this will be my parameter attribute. So we can copy it out from here. Add parameter will be bigger than 3. And you will see my strains are gone now. And if I use a null in here, now I got my strains in here separated. And this will be my shorts on the left side. Let's line it up first. And for my pans, I want to use a group delete here to clean it up a little bit. Afterwards, I want to use a name. I'm calling it pans. And now let's poly reduce it. So this will be my poly reduce. And I need a time shift in here. So I also have a freeze frame of this. My first frame of the pans will be frame 6. So inside here, frame 6. Let's plug this inside here. And if I reduce it to maybe a value of 20, we now got a low-res version with the animation. We can also copy over this part here. So let's copy it to here. Great. So at first I want to use my proxy, plug this in here. And I also need my render geo, and I will plug this in here. Now we can merge it together. And you will see now that we got under the name, because we need to plug the name into the render USD purpose. So we got our name and our USD purpose here. Great. Now let's move on and do the same for the strains. But inside there, we will start with a sweep node here. Let's watch the result. And let's increase the radius to a value of 1. Looking a little bit better. Let's also watch it through the camera. But I think we can work with this here. Yeah, let's work with this. Now we need an attribute delete. And I want to delete everything except my velocity. And the rest can stay as it is. And I will give it a name as well, calling it strands. And now let's again use a connectivity in here. Run it over the primitives. And we're using the same technique from our point deform here. So let's copy it over. And the connectivity will go inside here. And the third input will also go into the connectivity. Now inside here I will use my class attributes. and also inside here. And I want my class attribute on the points this time. And I'm using my frame 6 as a start frame. And this is working pretty well. So these are my strains now, pretty low res, but they are looking good. So we can also give it a color. For the pants, I'm using a more darker color, something like this here, looking good. And we also can copy it over to the strains, like so. Now let's copy our proxy and render geo. So like so and like so. And from the name, we also again plug it into our render USD purpose. We merge them together as well. Plug this in here. And the other merge goes into this merge. And same for this here. Inside the attribute wrangle, we got our pairs for the pants and also for the strands with the render and the proxy geo for each of them. Everything is working. So this will be my pants. And again, the same frame range. And we hit save to disk. I will also copy over the destruction to here. And I will call it my pants. Now the next thing we will create is maybe the ground here. And for this, we have this part over here because our destruction is only in the middle of this, as you can see. Now let's use the collision outside and plug this over here. Maybe I will move this here a little bit to the right side. I will paste this in and let's give it a name. I will call this here my ground, and I'm using a poly reduce again with a value of 20. Looking good. Now we can copy this part from here, paste it over like so, and we're using a merge afterwards again. Plug this inside, and I think I will just plug this merge inside here. So we're having the destruction and the ground together like so. So let's save it to disk. The next thing we can create are our smaller debris, and for this we're using our debris here. Paste it again into an object merge, and we already got our name attribute, so we don't need to create it in here. And we can use for each primitive loop here, because we still have our variant attribute. So inside the loop, we go into piece attribute and calling it variant. So we only have 3 loops because we have 3 different objects in here. And we want to create a bound, plug this inside. So we got a really low res version here, so just a bounding box. And we need an attribute transfer after this. Plug this inside and also in here. This goes into the end of the loop. And I want to transfer my name and my variant attribute. I don't need something on the points. And I also don't need a distance threshold in here. So we got both of them here. Great. And again, we need this part here, over here. Let's plug this inside. So we need the proxy in here. And my render geo will go from the object merge into the render. Great. I maybe want to change the color here. So let's use a brownish color. And maybe a little bit darker, like so. And at the end, we again using this part from here, plug this over, paste it in. And this will not be my pants, but my small debris. And this time we don't need 40 frames, but we can use a current frame because we can scatter it later on inside stage. We will hit save to disk. And we can copy basically the whole setup over, taking the pants here, calling it small debris. And now we need our dust particles. So we're using our dust variants here, paste it into an object merge and plug this inside again. We don't have a name in here yet, so we need to select both connections here and we create an attribute wrangle, delete the second connection. And let's move up to our small debris and we can copy out this path here, plugging it inside, run it over the primitives, and this will be not my debris, but my dust. So we got our dust 0 to 2. And the rest also should be working. I maybe want to change the color to a brighter gray, like so. And this will be my dust. And we can hit save to disk. Let's also copy over the small debris and we call it dust. And the next thing we want to prepare are our character. For the character, we're creating a new blast in here. And let's select everything from here. And again, maybe this much from the top part here, hitting enter. And delete non-selected. This will go into a null, and I will call it character, and we paste it down again. From here, I maybe want to move it a little bit. So let's display our destruction scene, like so. And we move into the camera, and we will see our foot is a little bit in the ground. So let's move them a little bit up. So we place a transform afterwards. And I maybe want to use a value of 0.003 or 0.1, like so. Looking a little bit better. We will take this. Do we have some velocity on here? I don't think so. So we can use a trail node and use compute velocity. So we got our velocity again. Great. Now from here we want to separate the foot and also my leg. So we can make it a little bit different. So let's create a new blast node in here. Or we will maybe do it with a split node. So let's use a split node, plug this inside. And we only want to select our primitives, like so. And we're using the foot here, or the sock, and the leg, hitting enter. And now let's give it a name. This will be my foot. And over here, this will be my shoe. Great. Now I maybe want to move it a little bit more to the right side. So I can create another null in here. Also call it foot render. And this will be my shoe render, like so. I'm pasting this both nulls into object merge. I also want to make them blue. And we're using a merge in here. Let's connect them. And we can paste this here over to the side. Let's plug this here into the render and deselect the proxy. And we're using a merge afterwards. Plug this inside here. I also don't want to see my ground anymore and the velocity. And for this, we're using a polyreduce again. So let's use, we can maybe copy it over from here. Let's copy this here, paste it down, and let's plug this in for the foot. Working great, also with the animation. And for the shoe, we maybe want to do another workflow again. So we don't use this technique, but my point deform again. So let's plug this in here, this in here. This will be only frame 6. Let's plug this into the second input. And my shoe into the time shift and also in the third input. Let's visualize the result. This is looking really low res here, looking good. But I maybe just want to keep 5%, so it's even more low res. Now let's also give them in color. So this will be for my shoe, and this will be for my leg proxy. My leg will be white, but my shoe, I will use a brownish color here. So something like this, maybe something more like this. Now we can merge them together again, plugging inside here. And this goes into my attribute wrangle here with the proxy. We don't need this color anymore, but this is looking good. We can also go to our primitives and watching the path, but we don't need this path here. So let's delete this here first. So we're using an attribute delete, and we want to delete the path and also our groups. So group delete as well, and all the group names. So my primitives are clean now. Now we got the names from here. And afterwards, we need our attribute wrangle with the path again, and also our USD export file. So now we got the path with the USD purpose, render for the foot and proxy, and also for the shoe, the same thing. This will be my character, also a frame range of 40 frames, save it to disk. Now let's watch if everywhere are my velocity as well. So inside my pants, we definitely have our velocity here, as you can see. For the destruction, let's watch it in the render. I think there is some missing, so we can again plugging it before the retime. So let's add a trail node over here using compute velocity, plug this inside. And now we got our velocity here. Great. And we need to hit save to disk again, like so. Great. And the last stuff we need are our smoke here. So let's select our Debri smoke. I will paste it down here into an object merge again. And let's use a file cache. I will call this smoke. And I will save it into an BGO file again, into my USD folder, calling it $s. And also this will be just my $s. I have, again, 40 frames. We also want to watch our name here. So we got the Debri smoke, and we hit save to disk. Great. Now we also need the names from here. So this was my dust. This was my character. Let's move it up. And this will be my smoke. I also want to select everything here, create another box out of it, move it a little bit down. And this will be my export. So again, I will make this red. So now this is my export. Let's select the small Debri text here, and I will call it USD export. Or maybe I want to give it a little brighter color, like so. Yeah, something like this. So let's move on to the OBJ level here, and we can pressing N and going to lobs with the wheel here. And we selecting lobs. So we're diving into the stage context. And let's start with importing our camera. And for this, we're using scene camera import. And I will call the destination path world/cam. And into the force object, we're selecting our camera, like so. And after this, we're using a cam edit. Now let's select the camera here and place this inside. And inside, we're going to the sampling tab, and we're using a focus distance here and also an f-stop. For the focus distance, we're using a value of 0.4, and the f-stop will be a value of 14. Now let's add a merge over here. And we also want to make it clean, so we're using a node again. We call it camera. I will make it large and also hide the background. Let's select everything and create a box out of it. And for my cam, I will use a blue color. Now let's use a reference over here. This will be my character, and I will type in the prim path /world/source path for now. And let's import in the file pattern the character. So the character USD here, let's place it in. And we got our foot. And if we hit render, we will see the high-res foot like this. Now let's plug this into the merge here. And let's visualize it together with the camera. And this is looking good. We also need a material library here. I will place this into /world/materials. And this will be my character material. I will also use the text box here, call it character. And let's create a box out of it again. And my character will be a color like this here. We maybe also want to import our pants for this. So we're using a merge over here. Let's place this inside. Use another reference. This will be my /world and pants in here. Now let's paste also the material library over here. This will be my pants material. And let's also paste the pants inside here. Let's move a little bit forward. Looking good. Maybe if we change the background here, we can see it a little bit better. So we're using a dark gray. And here you can see it. Looking good. This is also my world materials. We can plug this inside here. So we got both together. And together with the camera, it will look like this. Looking good. Now let's move on and we will import our ground. But before we want to also call it pants here and create another box out of it. And this will be the same color as my character, or maybe a little darker color like this. Now we create another merge over here, and let's use another reference as well. Again, calling it world/world, and this will be my ground, and let's import it. So I will import my destruction USD and paste this inside here. And again, we're using our material library from here. Paste it down. This will be my ground material. And inside here, I got my pants. But my pants are called pants1, but I want to just call it pants. So we're using a state manager here. Paste it inside. And under the scene graph, we make it bigger here. And we call it just pants, like so. Now we also want to import our debris. For this, we're using again a new merge. And for my ground, I again will copy maybe my character over, calling it ground. Let's select everything, create a box out of it. My ground is an orange color, like so maybe, something like this. And the next thing will be our debris. So we're using a reference for this. Let's use our small debris USD. This will be really big here, but if we hit render, we will see our normal debris. Let's plug this into an instancer, like so. And before we need a configure layer. And this will be flatten the input for stage. And from here we need a material library. But again, we will copy this here maybe, paste it down. This is not my ground material, but my debris material. Also in here I will type /world. And for my instancer, I will also type /world/instancer. My instancer will be my small debris. And this will be also just my small debris. And let's plug this inside another merge. So we also can add our dust here. So let's copy it over here. I will call it dust. And let's import our dust. And this will be my dust in here as well. Dust inst. And I guess I also call this small debris instance. And this will be my dust material. Let's plug this into the merge. And we're plugging the merge into the other merge as well here. We can deactivate the instances here for now. And let's move this here a little bit over there and this over there. So we can grab the ground again. This will be my small debris. Maybe I will make it like this. Select everything, create a box. And I will make it the same color as the ground. And this will be my dust. Select everything again, create a box. And this will be a gray like this. The last thing that's missing is the smoke. So for this, we're using another merge again and a reference. Now this will be also my /world. Let's go to file pattern. We're going to our smoke. And inside here, you will not see anything because the filter is to USD. So we have to filter everything. And let's import as a sequence. Let's import it. So we got our fog here. Great. And let's use also a material library again. So we paste this down here. Call it smoke material. And let's paste this inside. Let's visualize everything together. Also through the camera. And it's looking good. We also can hit render here once. So this is the shot now. And we can move down here, create another merge for the lighting later on. But for now, I will call this here my smoke. And one cool trick we can also use for the smoke, if we move up to our OBJ level, so we can pressing N again, go to objects, into our destruction. And if we use our pyrobreak volume before the export here, like so, we can hit save to disk again. And if we move back to stage, to our smoke, and reload the file, you will see the file has now the same color. So we have a better viewport in here. So now we also have the color on the viewport here in the normal view, and this is looking really cool. So this is our shot for now. Let's also take the small debris, we're calling it smoke, dragging it down a little bit, select everything, create a box out of it, and this will be a really brown color like so. Now let's move on to the scattering part, and for this we will starting with our smaller debris, and let's enable this. And at first we want to use our points, so we're using external points. Let's search for the subpath here inside the OBJ level. We call scatter. So we're getting both of our scatter points, the scatter debris and the dust. Let's take the debris for this here. We already loaded in, but we want to make some changes in here. So let's delete the prototype primitives here. Search for the debris 0, paste it in here, and let's use a star in here. And if we hit render, we will see also the smaller debris. But this is not working correctly because we also need to place inside our variant attribute and not a random, because now the scattering is random for each point here. So let's use an index attribute and we will call it variant, like so. Now it will work correctly, looking good. And we're doing the same for the dust. So let's go in here, again using external points. Let's paste the points in here. So scatter dust PTS, I don't want to visualize it like this. And let's use my dust prims inside here again, and a star. Can also visualize it like this if it's working. And we also need our variant attribute again, like so. But I think something doesn't work correctly here, so let's go to dark here, go to our camera again inside here, and let's only watch our dust particles. It looks right here, so maybe you want to change up the points a little bit so we have a little bit more. For this we can go to the OBJ level. Let's move on to our dust, and we want to have some more particles in here, so maybe 3000. And we can also move it a little bit inside the camera, so use a transform after the time shift. And we will move it a little bit in the Z direction, like so. Maybe 0.1 is enough. We can watch it here through the camera, and this is looking good. Now let's hit save to disk again in here, and also reload the file here. So again, we have one problem here. We have to reset the DOP network ourselves, and then we can cache it. And now let's reload it. And if we watch it now, we don't have the problem with the point duplication anymore. Then we can move back up. So inside stage again, we got our points instantly inside here. And this is looking a little bit better. Now let's watch it through the camera. So we got our dust particles over here. We can also visualize it like so. And this is looking pretty good, but I'm not happy now with my debris stuff. So we can move back up here to our controller after we visualize our fracture retime. I also want to build a little visualizer, so I'm using this here, paste it next to the controller into an object merge together with my smaller debris. So I'm using this here, paste a null, call it visualizer debris, paste it next to the retime fracture. And at the end we also need our dust, but I don't use it here, but my foot. So let's use the foot here. Let's copy it over, also into an object merge. And I also want to have my pants. So let's place this inside here, and we place everything into an object merge. Can also visualize it through the camera. And inside the controller, I maybe want to use another seat. So let's use another seat in here. Let's watch this here only with my foot together, like so. And this is looking pretty cool. Maybe I also want to have one big fracture in the front of the camera, like so. Or maybe have it here. So I can decrease the height of the animation. So I want to change my height. So let's use this here and move it a little bit down. The 1 we can also use. I don't want to touch the 1, but the global multiplier a little bit. Maybe something like this here, looking a little bit better. We can also do not display our velocity. And there, this is looking pretty cool. Maybe a little bit too much of the debris stuff here, so we can lower it a little bit. So let's go to our point selection, and we can use a value of 0.8 or 0.7, 0.79 maybe. Or 7.8, something like this here. We can also move this here a little bit around. I don't like this debris thing over here, so let's use another seed. I think I even want even less, so maybe 0.65. or just 0.7. Now let's also change the height again a little bit. So this time I want to decrease my maximum height, but increase my minimum height. Something like this here, looking pretty cool. And together with everything, it will look like this here. I also want to create a flipbook out of it, like so. Now this is a pretty cool result here, but I don't like that these two debris here on the left side are clipping into each other. So we maybe need to offset them a little bit. So let's go to our length inside here and we change the offset a little bit. Maybe also the roughness, something like this here. Now let's watch it again, like so. And let's do a flipbook again. Now this part here is not rotating correctly, but now let's just use another seat again. I think this is looking pretty cool. Now I need more height again. So inside here I maybe use a value of 3 again. Also a little higher rotate on the minimum. So let's use 0.1 or 0.15. Let's move this here a little bit down. And let's do a flipbook again. This is already looking pretty cool, but I maybe want to increase the spread of the debris now a little bit. So let's move into our debris. And maybe I also want to increase my P-scale maximum. And I maybe want to increase my global P-scale also a little bit to with a 5 behind the 3. And let's increase the spread to 0.045 or maybe even 0.06. Looking a little bit cooler now. Can also maybe increase it a little bit more to 3500, but I think that's a little bit too much. Let's use 2700. Yeah, something like this. And I move the slider a little bit over here. So we got some more bigger chunks. And at the end, we just have to go to our USD export again. And inside the destruction, we have to save it to disk again. And also one time for the smoke, we have to simulate it again one time. So just set save to disk in here again. But maybe we can simplify it a little bit to make it faster. So we just plug this into the transform over here. So it will maybe load a little bit longer. But we can move to frame 12, for example. So we got the new smoke here, but let's just cache it out as our BGU at the end here. So save it to disk. And from here we can move into our lobs again. And inside the smoke we will reload it. And the rest is also reloaded again. So this is looking pretty cool. We can also hit render once. And yeah, I will let it be like this. And we can move on. So now that we also have our scattering, we can move on and create the lighting here. And I will start with an Karma physical sky. Let's plug this into the merge here. And I will change some values here. So let's use a solar attitude of 9. And we also want to increase the angular size. I guess I will use a value of 90 here. And let's also increase the exposure. Let's hit render once. And inside the render, we will press this button here and enable color correction. So we press right click and make sure you have enabled ACES in here. Now let's also add a spotlight in here. Let's plug this inside. I will add another scene view in here, like so. So I can watch through my spotlight, and I will also keep it like this. Let's move it up here. And I think I will use a value like this here. I also want to increase my angle to a value of 30 maybe, and a softness of 1. Let's also change some base properties here. So maybe I will use an intensity of 0.1 and also enable color temperature. So we're using 5900. And for my spotlight, I also want to have an gobo. So we're using a light filter here. So I need an gobo inside here. So Karma light filter gobo. And let's add my texture like so. And we want to increase the intensity, maybe also the exposure to 1. I want to have a bigger softness. I'm using a value of 0.4 on the blur. Now let's go back. Inside the spotlight, we will go to my light filter and use the gobo on here. Now let's hit render again. And this is already looking pretty cool. We can go after the Karma physical sky here. And let's use a light mixer here. Let's plug this inside. And inside the light mixer, we can go to transform and also to the sliders and select everything here. Let's plug this over here. So we can single pass our spotlight. Let's enable it. And I will increase my spotlight over here. Maybe value like this. Also my intensity a little bit more. Let's visualize everything here. Maybe this is a little bit too bright, but we definitely want to have the spotlight like this here. But maybe we want to move the Karma physical sky a little bit. So maybe we use a value like this. So the suns come from the back left. But I guess this is also looking pretty good. So let's go into my light mixer again to the sliders. And let's increase the intensity here as well a little bit. Something like this. And also for my sunlight. And we also want the filter from the front. So for this we're using an area light. Let's place this down here. And we also can place the area light a little bit different. So we go to diffuse here. And we want to disable our smoke like so. And we can place it like this. So just place the foot here. And you will see automatically the light is placed like this here. So if we press to the top side, so the diffuse will be look from the top side as here, as you can see here. And if you to the front side here, the light will come from the front. And this is a really cool technique to also place the lights. And let's watch the results. And I also want to single the light. So let's place the light in here and single the light. I have to refresh my render here. And let's increase the light a little bit. Maybe something like this. And I will also decrease this light here a little bit more. Let's also maybe use a minus value. Let's watch it all together. So we got some highlights from here. But maybe let's go into my spotlight again. And we can move it a little bit over here or over here to get a nicer shadow. Let's solo light it again. And yeah, this is looking really cool in the single light. So maybe we can increase it a little bit again. Let's watch it again all together. And yeah, this is looking pretty cool. Maybe we will also move it a little bit up like so. And yeah, this lighting is pretty cool for me. So I can enable my smoke again. And we also maybe want to plug in a fog in here. So let's add in Karma fog box in here. And I will use a value of 0.25. For the shadow density, I'm using a value of 0.17. And the scattering phase, I'm using a value of 0.9. So let's watch the results. I go to my geometry spreadsheet and deactivate the light here. And yeah, this is looking pretty good to me. But I also have to increase my scale before. So I'm using a value of 5, 5, and 2. And now let's go to show and hide snapshots. We make a snapshot from this here. And let's also disable the fog box bonds so we can see the difference. And yeah, I like the blur from the frog in the background here. Looking pretty cool. Now let's disable the snapshot in here again. Enable the comma fog box. But I wanted to edit my spotlight in here. So let's go to my spotlight here again. And if we move this, so we will plug the spotlight inside here to all the other stuff. Now let's also disable the render again. I will move this up here a little bit. Let's enable the render again. Let's also increase the exposure for the view here. So we're using a value of 7. And let's move it a little bit more up. So maybe I'm using something like this here. Great, now let's move it back to 0. Plug the spotlight inside here again. And let's watch the end result. And yeah, that's looking pretty good. So we can disable the scene view here. And let's select everything. And let's grab the smoke from here. We call it light. And one problem with the light mixer here is if we would change the path here to, for example, /world, lights and $s, the light mixer would reset because it's binded to the prim path. And it's really, sometimes I'm not really a fan of the light mixer because of this. So make sure you always just place it at the end. I did the mistake here for now, but yeah, so you know for the future. All right. We can move on now after recreating this box here for the lighting. I will make it yellow. To our materials, and I think I will start with my smoke material here. So for this, I will go inside and I will create an Karma Pyro Smoke material. Plug this inside and let's dive in. And inside the Pyro shader, we can press P to visualize this here. And let's move up to our OBJ level before. And inside here, I go to frame 1. I go to my Pyro Bag volume. And let's open up here a new parameter channel. Like so. I will also pin it. Let's move back to our lobs level, going inside the shader. And we can copy over the density. So a density of 13. And also the values here. So copy the values over. Let's move back up. I will call this here my smoke. And inside here, I will plug in my material. So my material is over here. Grabbing the smoke, plug this into the material path. And assign to geometry. This will be my debris smoke here. And if we move a little bit further, we can hit render once. And I just have to plug my smoke version 1 in here. But yeah, this is looking good. And we can move on. I think I will start from the top part here. So I go to my character. And inside here, I have my foot and my shoe. So let's dive in. We're creating an Karma material builder inside here. And this will be my foot. for my sock. So inside my foot, I need an material X image. And let's place down my albedo map here for my color. This will be my color. I also have roughness, plug the roughness inside. We don't need metalness, but we also have a normal map. For normal, inside the roughness, we also have to change it from color to float. And inside the normal from color to vector 3. So this will be my normal PNG. And we also have a displacement. Let's grab the displacement here. And this will be a float as well. Let's plug the displacement inside here. We also need a material X normal map. Let's plug this inside here. And this goes into my geometry, into normal. My roughness goes into specular, specular roughness. And my color goes into my base color. In the displacement tab here, I will use a value of 0.01 maybe. Let's move back up. And I will assign my foot material to my material path. But before, I will dive inside here to my character material and just select the foot for here, so it doesn't double up here. Let's grab the render foot, plug this inside here, and we can hit render again. And yeah, the foot is way too big, so we have to lower the displacement here. So maybe a value of 0.0043. And yeah, this is looking way better. Now let's move on to my shoe. We're doing the same as for the foot, so we can copy it over. Let's copy this and paste this into the shoe. And inside my color here, I will grab the color for the shoe. Same goes for my roughness. And I also need my normal map and also my displacement here. Now let's plug the displacement in here again. I'm using nearly the same value, so 0.003. The normal map also goes into geometry and normal again. My roughness goes into specular, specular roughness. And I also have my base color here again. So let's plug this into base color. We move back up and we have another material. So number of materials will be 2. Let's select our shoe here this time. The shoe goes into my material path. And I grab my render shoe here and plug this inside. Now let's hit render again. And yeah, this is looking good. We can also visualize it together with the lighting. And yeah, this is looking great here. So we can move on. Now let's do the pants as well. So let's dive into the pants here. We also don't need our parabolic volume here anymore. And we have our strands and our pants here. So we also again have 2 materials. And I think I will copy over my foot from here again, paste it inside here, and this will be my pants, and this will be my strands. Let's dive into the pants first. For this material, I will make it a little bit different, but at first, let's load in the materials here. So I have my color map, I also have my roughness in here, my normal map, and also my displacement. Now inside the displacement, the value should be fine. And let's just move up here to this part, and let's use my pants material, my pants in here. Let's drag and drop it also in here and assign material to my pants render, and let's render it to visualize it. And yeah, the scale is way too big, and I maybe don't want to see all the time this yellow stuff here. You can disable this button here, so display selections, like so it's not visible anymore. Let's move inside here, and I will select the texture coordinates of all the nodes. Let's use a multiplane here. Inside the first input, we're using a material X texture coordinates. And in the second input, we're using a constant, material X constant, and the value of 5 maybe. And let's restart the render here. And I think this is looking way better now. Maybe I want to use a value of 6. But let's move on first, and we want to make some difference in the color here. And also give it some subsurface. So inside the subsurface, we're using a value of 0.8 maybe, and also a scale of 0.1. And I also want to make it more black. So let's use a color correct here. Material X color correct. Plug this inside here. And I'm using a saturation of 0.35 maybe. Lower the gamma to a value of 0.16. And for the gain, I also want to maybe make some changes in here. So let's move this up and recreate some noises. So for this, we're using a Material X 3D noise. I want to multiply the position here. So let's plug the multiplier into the position, and I move this here even further back. Also this here, like so. And I'm using the Material X position. So I'm getting the position of my cloth. And I want to use the object, not the world or something else. And let's use a constant here, Material X constant again for the multiplier. And I'm using a value of 35. Let's remap the result again. And I think I'm using a value of 0.2 and also 0.6. Let's plug this here into my gain, and we want to visualize the result again. And to make it even faster, we can disable the displacement for now. So just visualize it like this. Right, now let's plug this here into a mix node, like so. And we're using another color here, so let's drag this down here, or we can also move this back to here, maybe like so. And we're using another color correct here. Plug this into the second input of the mix. And I also want to change some values here, so I'm using a hue of 0.5. We can also visualize it like so. And for now, I also will disable my subsurface. I will lower the saturation here as well to a value of 0.8 maybe. For the gamma, I'm using a value of 0.6. So it's getting more the black color here. And for the gain, we also will lower it to a value of 0.3 maybe, or 3.5. So it's a really black color here now. My other color, we can visualize again also without my subsurface here. We're getting this really black color here, also this little brighter color. And we can mix it up with some noises here. And for this, we can copy down this setup here to here, plug this into the third input. And let's add an add node after the multiply for the offset. And let's plug this into the constant here. And inside the remap, I'm about to use a value of 0.4 and also maybe a 1. Great. Plug this into the base color. And I also will plug this into my subsurface color. Now we can enable the subsurface again. Now let's watch the result also. And we also have to activate thin walled, like so. And now we get the look we wanted. So let's also enable my displacement again. Let's plug this aside here. And for my strands, we can basically copy over the setup again, like so. Plug this over here. I will delete this stuff here, paste all my new stuff. And I only need my one color correction here in the base color, my roughness into the specular roughness, my normal again. So let's plug the normal into here. And I don't need a displacement for this here, so I will leave it over here. But for my normal, I need my normal map output. So let's plug this inside here. Right, we can maybe delete the rest here, so to keep it up cleaner. Don't need this here, or my material mix. So let's delete all of this. Right, now we can also visualize it again. But we will not see anything here because we also have to plug this inside here. So let's select our strands, paste it over here, and also assign it to my strands material, like so. And now we can visualize it with the render. This is looking good, and with the lighting and everything together, we can also visualize it once to see if it's working. But here, let's hit render. And yeah, this slowly starts to look really cool here. Now we will move back up here for the ground. And now let's create our ground, and for this I will only display my ground here. Let's dive on site. And I think I will copy over my foot material again. Let's paste it down. This will be my ground. Now let's dive in. And for this I will also start with importing my images. So my color node, my roughness, my normal map, so my displacement also. Now let's select everything again, and we again using the technique with the multiply. So we place down and multiply over here and texture coordinates afterwards. And we also need a constant, so index constant. Let's use a value of 5 here. And I will move back up here in the destruction. I want to plug this into my render ground and into my destruction, like so. And my material path will be my ground. Now let's hit render once, but maybe from a little closer view here, like so. Yeah, this is looking good. So now we can watch it through the camera, visualize this together with the lighting. So we're moving to here and hit render again. And this slowly starts to look really cool here with the textures. And now we can move back to here. And I maybe want to change my lighting a little bit. So I just did some changing on the lighting here. Readjust my spotlight and some values in the light mixer. And I'm pretty happy with this here. So it's a little more dramatic light here. Now let's move on and we will do the smaller debris. And for this we can use my ground. And maybe I also want to change my fog color over here. So let's dive inside here before. Maybe I'm using some values like this. Now let's move to my ground again. I will copy this here and paste this into my small debris. I will call this here my debris material. And also on here I will plug this into my material path. And inside my instancer, we're using my prototypes world, small debris, and the render one. Plug this inside. And let's use not a 0, but a star. So it's getting on everything here. and I don't need a displacement map. We can unplug this, and not such a high value here, maybe just in 2. We can also visualize it with rendering it, and here it is looking cool. We can also multiply the color a little bit. If we import our color, so material X color, like so, and if we would render this as a base color, let's hit render once, everything is white. So we got the color here on the points, but not on the debris, so we move back down here and into my smaller instancer. We maybe also want to copy my color, and this is not working, but we can maybe create another attribute out of this. So let's use another attribute wrangle over here, plug this inside, and this will be my f add color. So just call will be my add cd point x, like so. Now I got a call attribute here on my points. We can move back to lobs, and I use my call attribute in here. Now I can see all the different colors here, and we can use it as a multiplier for our color attribute. So we're using a multiplier in here. Let's plug this in here and the float value inside here. Plug this into my base color. And we got some darker debris and also some brighter. And we can use a fit range in here also, X range. And let's use the lower value as a 0.4 maybe, or 0.3. And I think this is enough here. Now let's move back up. And for my dust, this will be the simplest material, so just a camera material builder. And I'm using a different color here, so maybe something like this here. Let's move back. I will also call the material dust. And let's place the dust inside here. And also my dust render inside here. And I will replace the 0 with a star again. And inside my light, we can display it again. We can display everything again. Now selecting the camera here, and now let's hit render again. This is looking really cool, but we can also see we don't have our velocity on our debris here, so we need to change this. And for this, we move to our debris. Let's use a render geometry setting after the material, and let's press P again under motion blur. We don't want the velocity blur, but the instance velocity blur here. And let's use velocity blur, and we can hit render again. But there's still no velocity. I think we are missing a velocity attribute. Let's check it real quick. So we can go on here, select our render, for example. And is there a vel attribute? I don't see any. So we need to import it as well. So for this, we're going to our instruction. And if we display the velocity, we can see there's non-velocity. So we can go to here, creating a rel node, plug this inside, and compute velocity. Now we got the velocity attribute as well. Move back to lobs. We will only display render geometry setting here. And let's hit render again. But here I will place in a star. Now we got our velocity attribute here. And now we can hit render on everything again. But here, Karma XPU. And here now we can also see the velocity blur looking really cool. But let's also check if our foot here has the velocity blur. So let's move to frame 5, for example, where it's in motion. And on the character, I will visualize only the shoe here, and let's hit render. Alright, and we can definitely see it has motion blur, so everything is working fine. Now we will move to the last part, the rendering. So for this, we're using a camera node. I will just do a really simple setup here, so you just understand how you get out. So we're using Full HD, selecting our camera. I want to use XPU, maybe 100 samples. Into the image output, we're using a filter. I'm using the Intel one. Inside the rendering, also under cameras, under the motion blur, we need velocity blur in here for the smoke. Let's hit render once with our render setting camera, like so. And in the USD render rob, we can set it to render specific frame range. We only want to render 40 frames. And inside our output picture, we maybe want to change the path here. We create another folder, and we will call it ground destruction. And I don't want the hip name in there, only the $S, and this will be my destruction only. Now let's hit save disk, and you got your render out. One problem we're facing as well, I saw it in my ground fractures, creating render here. You will see that the texture is on the inside a little bit distorted here, but not on the top side. But let's also watch it without motion blur. So we're using a render geometry setting here, the motion blur, and disable it. Here you can see it better now. And we want to fix this. And there's also a really cool way, and easy way for this. So let's move to our object level. We move to our fracturing here, and after the blast node, we want to add some stuff. So let's move this down. Also this here. Let's select everything, move it down. And I will start with an for each name primitive, so a loop, and also a compile block to place it around it. So this goes in this input, and the compile begin goes in the first input. And also in my for each loop, I want to add multi-threaded when compile, so we can use all the cores from our CPU. Now let's start with an UV unwrap, place it in here. Let's also connect this to here, and I will place a null afterwards, and now it's working. But we only want the inside here and not everything, so let's split it up, like so, and we merge it together afterwards. So let's add a merge, place it to here, and inside here we're using the inside group, and now you will see we only got the inside here. Great. Let's display our UVs as well, and this are our UVs now with the UV unwrap. I will give it a little bit more space, something like this. And we have to enable single passes, like so. Now let's go to our piece. For the spacing, I'm using a value of 0.75 maybe. Now let's use an UV layout afterwards. Place it down here. Doesn't make it really better. So we can use an UV flatten. Place it also down. And this here looks really weird, so it's getting more stretched again, but we don't want this. So let's add an UV auto seam. Place it down, but we get the group attribute called seams. And let's add this to the seams group for the flattering constraints here. So we can clean it up again. Let's press 5 here. And maybe we want to change some stuff in the UV unwrap. Maybe also 5 panels. And we also maybe want to use inside the UV auto seam existing islands. Looking a little bit better. Great. Now let's merge them together here. So we merge this here together with our split node. And I want to use all the passes now. And let's also use all the passes. So let's go in here, deactivate single pass, and let's use auto update again. Great. If we use an explode view now here, so let's add explode view, you will see it seems right for the first beginning, but also our top view doesn't look really right because the UV tiling is too big here. Let's add an UV transform over here. For the scale, I will copy down copy parameter and paste it into the other parts here. And let's add a value of 15 maybe. It's looking nearly the same like this here. But it seems right on the first beginning. But if we don't use the name attribute but nothing, you will see the geo is not connected here anymore. And this will be a problem. So we also need to fix this here. So let's add another for each name primitive with a compile block again. So compile block, plug this over here. Let's move them inside here. And we want to use a fuse node in between. And inside the for each end, we also want to use multi-thread again. Let's watch the result again with an exploded view. Plug this down here, visualize it, and I go to auto update again. We maybe want to lower the value, like so, something like this. And we see our normals looking a little bit weird here, so we can recompute affected normals. We don't want this, so like this. Let's plug this into our auto attribute delete. And watch our transform pieces. And this is looking all right now. And also again, our pieces are connected. So this is looking really cool. Let's clean it up real quick. So we're moving this over here. I don't need the null anymore. We can move this over here, like so. It's the exploded view. One problem we have is that our outside ground, so let's display it, will have a bigger tiling than the inside. So we also have to copy over our UV transform. So we can select it, pressing Ctrl, Shift, and Alt, and drag it over. So we reference the wool node, and let's move it up to the top and place it before the collision outside, like so. Everything should be fixed now. Now we can move down to our destruction scene and go to our destruction USD file and hit export again. Now we can move back to lobs, go to our ground material. I will reload the file. Let's visualize it, and I hit render again. And now the texture is looking really off because the tiling is not correct anymore. Go to our constant here, and I'm using a value of 0.2 maybe. Looking better again. Maybe 0.3. Yeah, I think 0.3 is a little better, or maybe 0.25, something like this. Let's move to our debris. And you will notice that the UV here is now lining up better with the other parts. So there is no stretching anymore. Looking great. So for this part and for this here as well. Now let's activate the motion blur again. And if we move back down to our foot, Let's also watch through camera, and we hitting render again once. Yeah, this is looking great. And yeah, with this, we have reached the end of our course. Through the course, we explored a wide range of topics, including building a fully procedural destruction setup, creating a dedicated controller for it, running a vellum simulation, and so much more. The goal was not only to achieve a final result, but to understand the underlying workflows so you can adapt and expand them for your own projects. And if you're interested in diving deeper, be sure to check out our other courses on voxer.com. And yeah, thank you for taking part in this course. I hope you enjoyed, and I hope to see you again in future courses. And with all that said, see you in the next one.